All right. Hello. Welcome back to this. Part 33 of this is what this is. Um, it's been a little while since I last did this. I had a cold, and that wasn't conducive to talking in front of a microphone for hours. But I'm feeling better now, so we will continue. What are we continuing? We are continuing to write a WebAssembly interpreter in Ruby. As always, I'm doing this mainly to have fun, and there's also an element of wishing to demystify WebAssembly if possible, and also just share a little bit about how I go about working on something like this. Reminders for myself. Oh, hi, Chris. Welcome. I'm doing this mainly to have fun. Doesn't matter if if it doesn't work. I want the code to be correct. Doesn't matter if it's not fast. I want the code to be clear. Doesn't matter if it's not clever. I'm doing it in pure Ruby. I'm doing it with no dependencies. So that's the idea. I'm actually really keen to get back into it because it's been a week and a bit since I last did this. So I'll get into it in a sec. But of course, I do have to do a little brief retro, which I will get through as quickly as I can. So last time we got a load more table and memory stuff working, so sort of persistent data related stuff. Cranked through a bunch of that, and that included making call in direct work properly, which previously was working in some places but not enough places for the call in direct test script to pass. And also I finally tackled the bulk.wast bulk operations tests. After weeks of it being sort of stuck in on the pending list. It turned out to be a bit more involved than I'd expected because it actually covered several different bulk operation instructions for tables and memories, stuff like copying the possibly overlapping regions and all that good stuff. But that was good. I kind of, made progress, crossed a load more stuff off. I needed to think more about the runtime representation of those things. I mean, specifically, I needed elements and data to be around at runtime so that memories and tables could be sort of initialized from them. So I'm hoping that's all been put to bed for the most part. It all seems to be working. And there were a lot of sort of there were several of those table tests that were just testing different aspects of tables, and they all were passing by the end of the last stream. So yeah, I'm hoping I'm basically done with the worst of that. Although I expect all of the implementation of those things could use a bit more love, a bit of refactoring, probably making faster if possible. But I'm not going to do any of that until I'm confident that everything else is working. And then I'll come back and think about can I clarify or optimize this code. I said last time that abbreviations are making the AST and the interpreter way more complicated than it needs to be, and that I want some kind of preprocessor. Well, I've thought about that a bit, and I now feel more strongly that that's the thing that I want. And having had that nice spurt of progress on getting more tests to pass last time, I think this would be a nice opportunity for me to actually start doing that, or do the worst of it. And that's because I think it'll let us remove a bunch of complexity and just make the whole project easier to understand, which of course is really a large part of the point of doing this in the first place, is not just so that there's another WebAssembly implementation, but I want to try and build one that is at the very least understandable and maintainable and kind of has a little bit of educational value to it. So yeah, I've sort of talked myself into the idea of introducing a little preprocessor in between the S-expression parser and the AST parser, and so I think I'm going to have a look at that today. Chris Setter in the chat says, I enjoyed your Elrog talk about streaming, particularly the multi-video view thing that was like the scene from The Matrix. Thanks, Chris. I'm glad you enjoyed it. I enjoyed your talk as well, which was extremely good. Chris talked about the mob tool for making mob programming easier. So that was good. And in fact, that was what I was going to mention. I'll just briefly mention, I did give a lightning talk about this project at the London Ruby user group on Monday this week. And that was fun. It was nice to talk about some of this in public instead of just, secretly with my friends asking me what I'm doing. And it helped me to get some stuff straight in my head about what the point of this project has been or hasn't been. The video is not available yet, but I'll put a link in the description below once it goes online. So if you're watching this in not live, there should be a link to it in the video description. Chris said, it didn't answer the biggest question I had, which was how you manage to sit and work so long without a break. I couldn't do it. That's a good question. If you pan the camera down slightly, there's a whole network of pipes and buckets, and there's just a whole life support system in this room. That's a good question. I don't really know. I think I was sort of surprised that when I started doing this, I thought the sessions would be like an hour or 2 hours. And I think the first couple of them were pretty short by later standards. I think they were sort of maybe 2 or 3 hours long. But I mean, to be honest, what happened is that thing where you get into the flow and you're trying to solve a problem, you're trying to get into it. And then hours fly by and you look at the clock and you're like, oh my God, how can it possibly be 2:30 in the morning? I feel like I've only been working on this for 45 minutes. So really, I don't know how I've been able to do some of those longer streams without a break. But yeah, I think it is just that. I mean, I don't know. Can you get into a flow state when you're constantly narrating your thought process? Maybe not, but it's definitely when I've hit my stride and it's been fun, the time just flies by and I'm not sitting here thinking, oh God, like when I've been doing it for 6 hours, that's, well, I won't incriminate myself too much, but let's just say there have definitely been days at jobs in the past where I haven't done 6 hours of sustained coding or indeed any kind of work in a row. So yeah, it is a little unusual to be able to sit down and just plow through stuff like that. But by the same token, there have definitely been weekends, particularly with some of the stuff that I did as part of London Computation Club. I remember there were like Saturdays where I would wake up and then with my morning coffee, I would start hacking on some kind of thing for London Computation Club, and then before I knew it, it would be 5 or 6 p.m. and the whole day will have just flown past while I was hacking on something for fun. So I think this has got a little bit of that flavor to it. Hi Harry, welcome. Harry says, will your Brighton Ruby talk be uploaded anyway? It was fantastic. Thank you, Harry. That's very kind of you to say. I don't know. I don't know. You'll need to ask Andy Kroll about that. I think I saw on Twitter or Mastodon or somewhere that he was intending to upload the videos of those talks, but I'm afraid I don't have any information about that. I did try to record that talk. I always try to make a sort of backup recording of talks on my laptop as I'm giving them, just in case I want to release like my own version of the video using the audio and the recording of the presentation on my laptop. But the recording didn't work at Brighton Ruby, so I don't have any kind of, even if I wanted to, I'm afraid I don't have a recording of it. So I don't know. I'm sure the videos will be online at some point, but I don't have any information or control over that. So speaking of LRUG, one interesting thing I realized while I was writing my lightning talk is that we've now got 59, so almost 60 test scripts parsing in test.sh. That's almost 60 out of a possible 90 tests. And I was quite surprised when I noticed that. Like, that's really crept up on me, but it feels like significant progress. It's like 2/3 of the way there, sort of, if you ignore the skipped assertion. So the fact that, we're not doing any validation at all, so there are no sort of type errors, there are no runtime exceptions, there are no parser errors. So all of the stuff that's to do with like non-happy path stuff, I haven't even thought about yet. But in terms of like happy path assertions, kind of 2/3 of the way there, and ignoring any kind of weighting to do with like, by which I mean maybe the ones I haven't done yet are all way more difficult, and so they should be weighted more heavily than the ones that I have done. But yeah, it was nice to realize that I have actually, in some respects, broken the back of it. So once I finish faffing about with the preprocessor, I'd really like to just blast through the remaining 30 odd tests and then look at unskipping as many of the assertions as humanly possible. But like the blasting through part, now that I know that I'm basically 60 out of 90, it makes it feel much more achievable to just smash through the remaining 30. And I think probably it is going to continue to get a bit easier, because as I flesh out more of the infrastructure around the parser and more of the runtime representation and stuff, I think I'm having to do less and less work for each new instruction I'm implementing, because there's so much more infrastructure around it. And the reason I'm noting it during this retro is that this is the first time I've felt like I could even vaguely perceive any kind of initial finishing point for this project. Like, it's still miles off. But now, looking at this number, I can sort of imagine it. I can sort of imagine all 90 of those test scripts passing, and then going through and implementing enough of a type checker and enough error handling in the parser to sort of get all of the other assertions passing. And then I'd be able to sort of celebrate and say, like, well, all of the core tests are 100% passing. Like, that's an exciting thought. And yeah, it's just fun to think about how far we've come with that. So, yeah, I don't want to celebrate prematurely, but I do like the idea of, being able to conceive of this being eventually, if not finished, then at least reaching a checkpoint where I can say, I've built something that can do something. And then, of course, there's, I could list a lot of other things that I could potentially do once all of those tests are passing, not least looking at the other tests that are in that repo that aren't part of the core directory, but I'll cross that bridge if and when we come to it. Chris says they might be secretly passing. Yeah, that's true. I haven't actually, maybe it is, maybe another thing that I should be doing fairly soon is another sort of audit of the remaining tests and try and figure out whether any of them are secretly passing. That's a very good point. So I might have a quick look at that today, actually. Harry is asking your slides up anywhere. No, sorry, Harry. I will consider doing that, though. I think, regardless of if and when the video is released, maybe I will just stick the slides up for my Brighton Ruby talk so that anyone who's interested can look at them. I will consider doing that. All right. Let's look at where we are. Test. Think everything's probably okay. Let me just try pulling in. Oh. Well, just looking at this, looking at the stat here, I can see that none of the files that I care about have changed in the WebAssembly test suite, so that's good. Let's just, now that Chris has sown the seed of the idea in my mind, let's just have a quick look at what's left. I mean, do I have any kind of list? No, I think I did. No, I didn't do these. Okay, so table fill, table grow, table size. Okay, right. Well, I'd forgotten about this. I'd forgotten that I actually hadn't completely finished dealing with the table stuff. And because there were just, I think there were just 3 instructions I haven't implemented yet. And so the tail end of these table related tests wasn't quite done yet. Let's just have a look though. If I'd thought about this, I would have, is my vim foo good enough to do anything useful here? No, that's not right, is it? How do I... Oh. I don't know how to do this. just going to just pretend you're not watching me do this. I just wanted to put these in alphabetical order, that's all. And I don't really know how to do that, so I've just bodged it. The auto indentation is not really helping me here. So now that I've got those on their own lines, I think I can I do that? Yes, okay. So these are the ones that are currently parsing. Yeah, good point, Chris. Chris says, I only mention it as it might be a bit anticlimactic to get to the last test and find out the job's already done. So yes, I agree. It would actually be nice to have a sense of like what is outstanding. Well, let's just make a new thing here that's like remaining tests. Maybe this can... Yeah, maybe I'll make this one of these things, a bulleted, to-do list. I don't know what this. I don't know what Notes calls this. So address done. I mean, this isn't going to be hugely ergonomic. Yeah, sorry. I'm just going to eyeball this. We've done address. We've done align. Haven't done these ones. Binary, leb 128. I'm not going to type .wast after all of them. Binary haven't. So, I mean, I don't know what binary is, but I assume that's to do with the binary format for WebAssembly source, for WebAssembly files, which I haven't even thought about yet. Block I've done. BR, BRF, BR table are all done. Bulk is done. Call is done. Call indirect is done. Comments is done. Const is done. Conversions is done. Custom, haven't looked at that. Data, yes. LM, yes. Endianness, exports. F32 bitwise, F32 comp, F64 bitwise, F64 comp. FAC, I've done that, can't remember what that is. Float expressions, float literals, float memory, float misc, yep. Forward, func pointers, global, that's all done. I32, I64. Yeah, I mean, I have done quite a lot of these, haven't I? Oh, I haven't done imports. That's interesting. Because, I mean, I have done a lot of work on imports, but not, apparently, systematically. Inline module. Haven't looked at that. Integer expressions, integer literals, labels, left to right. Linking. Don't know what that is. Load I've done, local get, local set, local t, all done. Loop done, memory done. Oh, right, memory copy I haven't done. Okay, that's interesting. Or memory fill. These might be working. It's possible because I had to implement some of that stuff as part of bulk. So those I might already, Chris might have already identified a couple of ones there. Grow, I've done. Init, I haven't. But again, I think it's possible that I implemented that as part of bulk. Memory redundancy. Size is done. Memory trap is not done, but I don't think I assume that's going to be assertions that raise exceptions, and I haven't thought about that yet. Names is done. No op is done. Ref func. Again, I feel like I've sort of worked on that a bit, and is null I've worked on a bit. So some of these belong up here in these like stuff that I might have already implemented. Return is done. Haven't thought about run. Don't know what that is. Select is done. Skip, stack, guard, page. I haven't looked at, but I've done stack. Oh yeah, start. This is like a special, I think you can set a start function for a module, almost like a main function for a module. Haven't thought about that yet. Oh, thank you, Chris. Run, run is the thing that runs the tests. Thank you. Oh, I really should have just checked that off. But no. Okay. Yes. Well spotted. That is not a WAST file at all. Thank you, Chris. Start. I've done store. Switch. Haven't thought about that. Table sub is done. Table is done. Table copy is done. Sort of interesting that the notion of alphabetical order differs. Oh, it's because of the .wast. Yeah, okay, fine. Table copy. Oh yeah, table fill was noted up there. I've done get. Haven't done grow. Done init. Done set. Haven't done size. So I think these three were these three. Token. I do remember looking at that, but I can't remember what it is. Tokens. Traps. Yeah, that's okay. So we're getting into all the stuff I haven't thought about yet. Type, haven't looked at. Unreachable, haven't looked at. Unreached, invalid, haven't looked at. Unreached, valid, haven't looked at. Done unwind. And then there's lots of UTF-8 ones at the bottom here. Import, oops, sorry. Import field, UTF-8. Oh dear, I'm not very good at typing this. Import module, UTF-8, invalid encoding. Okay, so if I'm right, this should be, what, 31 of these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I screwed that up, I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Well, maybe there aren't exactly 90 of them then, because I was expecting there to be 31 here, but maybe it was maybe run was, you know, obviously I've miscounted or I've got confused somewhere, but that's fine. Right, run makes 30, yeah. Oh, okay. Doesn't really matter, does it? I've confused myself with integers, so let's just pretend that didn't happen. Okay, so I'm sort of curious. What do I think here? I'm just going to try running a few of these imports. Now, I'm not surprised that imports doesn't work because I haven't sort of systematically implemented that yet. So I'm sure that there are, I mean, yeah, the parser has found some kind of import that it doesn't know how to deal with yet. So that's fine. That's sort of what I would expect. Let's try some of the memory stuff. This is hopeful. Okay, so memory copy. Yeah. Memory copy is working apparently. Again, not particularly surprising because I implemented that last time, but I'm a little bit surprised that it works well enough that it passes at least some of those assertions. Memory fill also. Let's try memory init. Blimey, this programming lark is easy. I don't know what memory redundancy would be, but apparently I do know because I've made it pass. That's good enough for me. Oh, okay. Well, copying that wasn't as clever as I was hoping it was going to be. Now, memory trap, I think there's a chance that everything in that is going to be skipped. Oh, no, not all of it. Okay, well, I'll take all of the assert returns in there. I think that's legit. So memory trap. I think there is a chance that ref func and ref is null will work. because again, I've had to implement those as part of some of the other tests that we've been working on. Yeah, there we go. Wow. Well, Chris, I'm glad you mentioned this, because this is going to be more tests than I've got parsing in any previous session. Ref func is parsing. Ref is null, also parsing. Wow. Okay. And I haven't thought about switch, have I? It doesn't ring a bell. Wow. What is... Okay. Have I just forgotten implementing a switch instruction? Oh, right. There isn't one. This is just testing that, you know, blocks and branches and things work correctly, which apparently they do. I mean, I assume the intention here is that this is like, you know, if you used, you know, LLVM or whatever to compile a C switch statement down to WebAssembly, if you use like Clang, then I assume that you'd get something like this, that this is how, yeah, that this is how switches would be implemented, that you'd have this sort of table of places to branch to, and then the different targets of the different switch cases would be, they sort of have to nest a load of blocks here to sort of get labels and to achieve falling through. So that makes sense to me. So the fact that I don't remember doing anything to do with switch is fine. Chris wants to know, what does custom do? Well, let's have a look, shall we? Well, firstly, let's see if it passes. Oh, well, they're all skipped, but I think that's okay. I think I should add that. So what is this? All right, so this is all binary module stuff. And it looks like the only assertions are assert malformed. So I suppose I can add that for now. Let's add that. Let's pretend I thought about that earlier. Put it in that alphabetical order. I mean, it might be that the binary ones are, you know, in the same boat. Yeah, they are. Okay. Well, I'm gonna add them then. Binary leb 128 binary custom. Okay, we know that imports isn't parsing. Might as well look at inline module, I suppose. Okay, that's no good. I don't know what linking means, but that is also just not even parsing correctly. I might as well try all of these, mightn't I? Skip stack guard page. Nope. I'm almost sure start is not going to parse. Yeah. I think I know that table fill, table grow, and table size don't parse. Table fill, table grow, table size, those are indeed all failing. What's token doing? Don't know, but it's fine. Token. Let's just see what that is. I think this is stuff that tests the parser. Yeah, test tokenization. Oh, right, but the testing of the tokenization is just making sure that you get a syntax error, which I don't do yet. Well, I sort of do, but I don't have a way to assert it, is what I mean. And this is just about... What is this about? Are there any assertions in here, or is this just stressing the parser to make sure that it's able to successfully parse this whole file? Obviously, these assert malforms I'm not executing, but... Yeah, I think I would expect this to pass, actually. Oh, no. Right. Okay. Oh, that's interesting. It's looking for... It's trying to import a function called print from spectest. Right. Is that legit? Because if it is, I should just implement that. Oh, yeah. I guess that's just printing a new line, or well, it doesn't matter what it's doing, because none of them do anything. But that's one that I can... That's one that I can support. I'll come back to that. Traps maybe is parsing because I'm ignoring all of the assertions. Yes. So, I mean, obviously we're getting into cheating territory now, because like if there's not a single thing that's that is actually running in there, then it's a little bit vacuous to add it to this list. But I do think it's helpful because, for example, well, because what I'm trying to do is bottom out the search for assert return, which is the assertion I currently support, right? And so I think if I can, as long as I can include under the umbrella all of the files that don't even use assert return, then by the time I've crossed everything off this list, I will know that I've finished with that. And then there's a whole separate thing of like implementing the other assertions, and I might need to... I'm not sure exactly what I'm going to do at that point, because as soon as I implement some new assertion, half of these test scripts might start failing. I might have to back a load of them out of this list, or I might need separate lists to like, here are all of the ones to run the assert return assertions, and then here's a different list of files to run this particular assertion. I haven't thought about that yet. Nonetheless, well, I mean, I've convinced myself that it's fine for me to be doing what I'm doing, basically. Unreachable... I mean, that's got a couple of... There are a few green dots in there. So I don't feel too bad about that. Unreached, invalid. Fine. And unreached, valid. Fine. I think those are all skipped. I mean, this is making me feel a lot less excited about the fact that I've got so many of them crossed off the list, because I know that a lot of them are quite vacuous. But like I said, I think this is the correct thing for me to be doing. I'm just not... It's just taken a bit of the wind out, of my sails with respect to how much of an achievement it feels like. Like, this is not really an achievement, is it? Like, I just haven't implemented any of that yet. Let's try all of these UTF-8 ones. Yeah, these are all parsing, but vacuously. Yeah, I mean, I assume that the assertions in these files are all going to be to do with, you know, invalid either syntax errors or invalid binary format or whatever. So I'm just gonna leave that for now. But I can add all of these, can't I? So unreached valid, UTF-8, oh no, custom section ID, UTF-8 import field, UTF-8 import module, UTF-8 invalid encoding. Okay, so let me just run all of that to check. Let's make another tab. Yeah, fair enough. William, firstly, welcome, William. Thank you for joining. William says, something that will fail in the future and provide you with a quick feedback loop seems far from vacuous. And I think you're right. I agree. You're right. It's just I was bigging myself up about the fact that I have this big long list of parsing tests, and now I feel like I might have slightly overstated my case. But yeah, you're right, of course. Like, these all work as... They all work as regression tests, certainly with respect to the parser at least. every single one of these is actually implicitly asserting that the whole file can be parsed. So that's something. And then, yeah, the fact that as I change the behavior and particularly as I implement new assertions, keeping these parsing is going to be a lot more challenging. So, so now there's only 1, 2, 3, 4, 5, 6, 7, 8, 9 remaining. Wow, look at that. I mean, I might as well. This is as good as it's ever going to get. I should just stop the stream now. There's no way I can improve upon the productivity that I have just exercised here. So let's just add loads of parsing tests to test.wast. I could do 9 tests today. You're right, Chris. maybe this is when I said I could see the end of this project over the horizon. Like, maybe it's actually approaching me at the speed of sound and it's going to smash into my face as soon as, well, sooner than I expected. Add loads of parsing tests to test.sh. I'm going to try and keep Etienne happy by remembering that this is a thing that I can do. It turns out all of these test scripts were already parsing. Some of them are unsurprising, e.g. Memory size. Oh no, hold on. Those were already parsing. So what was unsurprising in this list? Probably is a memory one. Yeah, okay. E.g. memory copy.wast and memory fill.wast were probably let's say probably started parsing once bulk.wast was parsing. Some of them are vacuous, e.g. let's say maybe traps.wast is a nice easy example of that. E.g. traps.wast consists entirely of skipped assertions, so isn't really testing anything except the parser. But it's still useful to record which of the test scripts are currently free of assert return failures. There are now only 9 failing test scripts remaining in what's the directory? Oh, test core. I haven't thought about what I'm going to do when I start implementing more assertions. This will almost certainly cause some of the parsing tests to begin failing again. I'll think about that when it happens. Well, I don't think I have anything else to say about this, but what I do want to do is just get tokens working, because that feels like an easy fix. So in the interpreter, I just need to add something to spectest. Oh, it's interesting. I've only got print I32. All right, I said it doesn't do anything, but of course it does do something. It has to consume its argument. It just doesn't print it because I'm not interested in seeing the output of it. But I can just add print here. As just a function that does nothing. What's the nicest way to denote that? I suppose I should leave a space between the curly brackets, shouldn't I? Because otherwise it... Is that the right thing to do? Don't really write this this lambda very often. Anyway, let's see. So what was it? Tokens. Okay, yeah. So I can add tokens here. So let's do this. Add print function to spectest module. And I'll say this is needed by tokens.wast. And now I can say add tokens.wast parsing tests. I realize now that, oh yeah, this is fine. This is a slightly special commit message, isn't it? It's not it doesn't follow the pattern that I'd established for add blah to parsing tests, but that's okay, I think, because this was a bulk add. Okay, so now only 8 remain. I mean, that is sort of tantalizing, isn't it? I mean, I was pretty determined that I was going to look at the pre-processing thing. Now, the reason why I'm hesitating is I think imports is going to be quite hard to do. Because this is going to be stress testing the ability to support import abbreviations. So having... I assume the parser was failing on an inline import, you know, like this. And I just don't want to, go through and hack this into the parser in all of the places where I'm going to need it. I mean, maybe it's only 1 or 2 places, but I'm trying to dig myself out of that hole. I mean, maybe... Maybe I could make that the focus of the preprocessor, right? Like maybe that could be the thing that I use to kind of force out the infrastructure for the preprocessor, is just to focus on imports. Let's just look at how that looks. So let's just pick something that has an import abbreviation. Because yeah, this is what we need to do. This is the abbreviation. I mean, yeah, globals aren't very interesting, are they? Maybe function definitions are more interesting. Yeah, William, the whole issue here is that the inline import is literally syntactic sugar, in as much as the language specification, which is what we're looking at here, actually just defines it as an abbreviation. So you can see here, this is an example of the inline function import syntax, where you can say func, optionally give it an ID, and then you can have this inline import here. So you're not, when you do this, you're not really defining a function, you're actually just importing a function. Normally a function definition has a body. So you can see here, this is like a regular function definition, and it's got a sequence of instructions here that constitute the body of the function. here this in this abbreviation section, it's saying you can also just write the func keyword, an optional ID, and then if in parentheses you put import after it, this triple equals is saying that is actually just an abbreviation for this different S expression that is actually an import statement. And at the moment I've implemented this. I do not have an explicit phase that is just desugaring this expression. I actually can parse this directly, and I've got a way of representing an inline function import explicitly in the abstract syntax tree, and I would like to get away from that. So I think maybe what I will slightly pivot now and think about, can I set up the infrastructure for the preprocessor such that it is able to sort of arbitrarily expand abbreviations, and maybe I'll use imports as like my test case, because if I can expand all of the inline imports that I currently support, which would be, let's see, so here, yeah, for example, in parse function, this is the thing that supports inline imports by actually explicitly parsing them and then recording some information on the resulting AST here to track that this inline import was provided. I would just be able, if I was desugaring this in a preprocessor, then I could remove this from the parser, which would be a nice win. But the real win is that in the interpreter, I'm also having to deal with that representation down here. So I'm sure in build functions, yeah, so I have to do things here where I map over all of the function definitions, and then I have to check to see if they've got, this is the case where if they've got an inline import, then I fetch, you can see here, this is the thing that fetches from the exports of the module that's being imported from. It fetches the function definition from there. So I would also be able to delete this code. So I do think I'm going to do that. William asks, why does something that is basically a compiler target have syntactic sugar? I have no idea. That is an extremely good question. I don't know why. I mean, the only thing I would say is that this is only a property of the text format of WebAssembly, right? And I don't really know why that exists at all. Like, I'm sure that, if you were compiling your Rust program down to WebAssembly, I would be surprised if it ever gets serialized as plain text. I have always imagined that something like LLVM is just producing the binary format. I don't actually know that, but I assume that the WebAssembly backend produces .wasm files that are just in binary format. So I'm not sure why this text format exists at all. I mean, it's very convenient to have a sort of a plain text serialization of WebAssembly code. Obviously, it makes it easier to debug and stuff like that. But yeah, it's a very good question. I don't really know why the various bits of syntactic sugar are present here. I mean, maybe one of the design goals of WebAssembly is for it to be practical and perhaps even desirable for people to write it by hand. But as far as I can tell, like when I've gone looking for WebAssembly resources on the web as part of either on the streams or as part of sort of reading around the stuff I've been doing on the streams in between sessions, I couldn't really find anyone who was actually writing WebAssembly code. Like every single blog post or whatever that is notionally like an introduction to WebAssembly actually starts out by saying, well, first you're going to need to install, most of the time it's the Rust compiler, and here's how you configure it to emit WebAssembly, and now we're going to write our first ever WebAssembly program. We're going to write it in Rust, and then we're going to compile it to WebAssembly. So like if there's a community of people somewhere who are getting, entertainment out of writing plain text WebAssembly and therefore getting benefit out of this syntactic sugar. I don't know where those people are. So yeah, I don't know. It's weird and annoying. But the whole reason that I'm engaging with the plain text format in the first place is that that's the language that all of these acceptance tests are written in, right? Like I know that these aren't available as binary WebAssembly files because some of these aren't actually WebAssembly programs. These are test scripts, which is a superset of WebAssembly syntax. So things like, I mean, God knows what this is, but assert unlinkable is not part of WebAssembly. It's part of the test script format that is defined for the reference interpreter that comes with the WebAssembly specification. So I've sort of, although at one point I did regret engaging with the text format because it is quite verbose and has got all this syntactic sugar to consider, it's really the only way of being able to run these test scripts because they're just not, there is no way for them to be made available as binary. So yeah, I'm just sort of stuck with it, unfortunately. Anyway, sorry, I'm starting to rant and ramble, and when what I should be doing is focusing on the task at hand. So yeah, I think what I want to do is hook up a preprocessor that is able to, I mean, yeah, I wonder if it's, I'm thinking about verbs now. Like, what is that preprocessor doing? Is it just desugaring? Maybe it is. Yeah, maybe what I'll do is have a preprocessor that is initially just the identity. It does no desugaring, and I just stick it into the pipeline between the S-expression parser and the AST parser. And then maybe I could figure out incrementally how to desugar things like, you know, maybe this would be a good place to start. Yeah, expanding, William says that. Yeah, maybe. I mean, I was thinking of, you know, it could just be something generic, like sort of processing. You know, what does a preprocessor do? Well, it processes something else. You know, it's doing processing before some other stage of the pipeline. So I mean, I'm really just thinking about what the method's going to be called. You know, in the AST parser, this is just a recursive descent parser, and everything is called like parse underscore something. So maybe I'll just do like process underscore, you know, something. Maybe desugar is a bit, well, firstly, it's a bit of a mouthful, and secondly, it's a bit of a commitment to something specific, whereas process is hard to be any vaguer than that, isn't it? So hold on, why don't I just, instead of talking about it, why don't I just hook this up? So this, at the moment, this run_wast file is the one that is essentially I'm using to run these test scripts, and this test.sh script is also just running that, I think. Yeah, run wast. So at the moment, this is the thing that wires the pieces together. So it reads in argaf and sends it to the S-expression parser, gets an S-expression back. And then it sends it to the AST parser and gets the AST of a script back, and then it calls evaluate script. So I think what I'm going to do here is do something like, you know, maybe I'll call it desugared S-expression equals wasmina preprocessor. I don't really want to call it desugarer. It's going to be process script S-expression. And then this becomes desugared S-expression. So that's going to obviously... Well, let's find... What's a nice representative test that I can run here? Probably function.wast. Or is it functions? Oh God, what's it called? Oh, it's func, isn't it? Because that is the keyword. Yeah. So let's see, is there some importing in here? Oh no, there isn't. Okay, well this isn't going to be a good candidate for me to import. Well, actually, is there just a func import in here somewhere? Names. Well, there are surprisingly few of these. Which makes me a bit confused about like why I was doing this, why I implemented this in the first place, because apart from reffunc, which I just added, maybe func pointers, but I think the rest of these are from tests that I'm not currently running, so I'm not quite sure what motivated me to implement these inline imports in the first place. Maybe it was func pointers. Let's just look for maybe something more boring. Maybe I will do globals. Because they're syntactically simpler anyway. So yeah, this just, if you say global ID import, that needs to desugar to import global ID, basically. Like, this is almost, yeah, I mean, this is actually quite nice, isn't it? Because this is almost the simplest possible kind of abbreviation where, like, really we're just rearranging stuff here. And I guess it's the same for actually probably all of these inline imports. It's a similar kind of deal, right? Because because the syntax of the import statement is necessarily just going to include whatever it is that you stick in around the inline import here. You can see that inline exports are a bit more complicated because it involves creating a fresh identifier, which I don't really want to deal with yet. But imports is just, you're just scrambling the order of stuff in the S expression. So this would actually be kind of convenient for me to implement first. So why don't I do that? Why don't I yeah, I mean, global.wast has got a bunch of global imports in it. So I think that's probably a good candidate for me to, oh yes, well obviously. Oh well, that's what I was trying to do though, right? I wanted to I wanted to run a test and see it fail, and now I've done that. So this is gonna need a wasmin preprocessor. And yeah. Processor.rb. Okay. Okay, so we're back to uninitialized constant. What does the parser look like? Nothing very exciting. Undefined method process script, right? And this is just going to be S expression. Okay, not a list, nil. Okay, fair enough. So the AST parser is choking on the fact that we're returning nil from this, but if we just return the S expression verbatim, then now that's plumbed in. Doesn't do anything yet, but this is now my sort of entry point for doing the pre-processing, I think. Okay, so I'm going to commit that, I think. Let me just do a paranoid run the tests, but I think so. This is going to say like introduce trivial S expression preprocessor. This doesn't do anything yet, but it gives us a place to start implementing desugaring, i.e. expanding abbreviations before the S expression reaches the AST parser. Okay, so that's looking good so far. Now, the thing I'm thinking about here is whether I want to write some unit tests around this. Like, in general, I haven't been. I think because the acceptance tests are themselves a bunch of unit tests, effectively. Like, this just consists of a load of individual assertions that are testing. You know, it's not really broken up into... there's no description of where each unit test begins and ends, but that's essentially what these files have got in them. But at one point in time, I did... Oh yeah, it's just test, isn't it? So yeah, the last time I even looked at this was the 7th of January, and I think that was just moving files around. Oh yeah, maybe I need to... Oh, I don't know how to do that. Okay, fine. Anyway, it doesn't matter. The point is, I haven't looked at that for a long time. So let me just think about this for a second. I don't just want to write unit tests for the sake of it. What would the utility of writing unit tests here be? I'm finding it a little bit hard to imagine what the point of it would be, actually. You know, I'm a huge fan of writing unit tests, but in this case, I don't think the unit tests are going to add anything beyond what I'm getting from... Well... No, okay, there maybe is something interesting here, actually, now that I think about it, which is that it gives... Having a unit test for this... Okay, yeah, I've decided I am going to write them. Because what I want to do, I want to be able to do a sort of hand-over-hand, you know, climbing up this problem, right? And I think what that is going to look like is that I want to be able to... So at the moment, the implementation supports both inline imports of globals and explicit imports of globals, right? So this is an explicit import where you say import module you're importing from, name of the thing you're importing, and then an import description, which for a global is global, optional ID, and then global type. So I implement both of those things. Now what I want to do is just delete the code that supports this syntax, because I want the preprocessor to just desugar all inline imports into explicit top-level imports. So I think if I write some unit tests, what I can do... You know, the point is that if the if the preprocessor is successfully desugaring this into an explicit import, then it's going to be hard to see that, because all that's going to happen is that we're going to end up with some sort of unused code in the parser, right? Because it's now never going to see this syntax anymore. But if I write a unit test, what I can do is have a unit test that sort of asserts that the old syntax has gone away, right? So I can write a failing unit test that says a module that includes the inline format should be desugared into one that includes the explicit format. That unit test will be failing. Then I can make that unit test pass by implementing that desugaring. And then there's been no change on the behavior of the acceptance test because it was passing before and it's passing still, but the unit test has changed state. And the fact that the unit test has changed state now tells me that I can go and delete some code from the S expression parser, from the AST parser and from the interpreter, because all of that code is unused. And the unit test is sort of what is, attesting to that fact. No pun intended. So I think I'm going to give it a try. Let's just see. I mean, I might, this might be stupid, but, no, I don't need to do that there. I can do it here. Test preprocessor test. So what do the other unit tests look like? Let's look at S expression parser test. Okay, yeah. So this is going to be a similar kind of. So I'm going to require wasminer preprocessor. Yeah, I mean, these are all quite. This is all quite grim, isn't it? And in fact, this is going to get quite grim because you just think about what I want to do here. So let me just sketch out. So the input here should be something like module global. Let's look in this test and look for an example. Are these the only imports? They're the only ones that are actually going to have any. Oh, there's that one as well. Global I32. Okay, so yeah, let's say it's going to be something like this. So that's what the input is going to look like. And then the output is going to look like still a module. So we're going to leave that alone. But then this is going to become an import. And I think it's import spectest global I32. And then in here, we say global I32. Is that right? Import name1, name2, spectest global I32. And then in brackets, global. There is no ID in this case. And then the type. So I think that's right. So this is ultimately what we want. I'm going to not involve the S expression parser here. I'm just trying to think about what the least annoying way to build this data structure is going to be. Let me just double check what the okay. So it's just parse. Right. So yeah, so they're all strings. Oh yeah, and I'd forgotten that because a script is a sequence of potentially modules and other things. If we look at the sort of slightly informal definition of what a test script can consist of, it's a sequence of, could be a sequence of modules, but also other things, actions, assertions, meta commands. So yeah, I'd forgotten about that aspect of it. So it needs to be an array containing a single S expression. So I'm just thinking this, I'm just sort of thinking out loud, or by like pasting this stuff in, because I want to, if I'm going to bother to do this, I want to have something that's not going to be too annoying. I mean, maybe right to begin with, I could just go with what I've pasted here. Why don't I do that? So this is expected, actually. Yeah. So I'm going to do something pretty similar to what I did in this test. Obviously, this all leaves something to be desired, I think. Let's not worry about it being an enumeration or anything. So this is the test I want. Right, so it's just Ruby minus I lib test preprocessor test. Yeah, and then there's the, it's raising an exception, and not a very illuminating one, but obviously because this preprocessor isn't doing anything to its input, we're not getting what we wanted there. Okay. So I'm just thinking about like, what order do I want to excuse me, what order do I want to add stuff? I don't think I have any provision in this test script for like pending unit tests, you know, so I can't, I suppose I could add it, but I think what I'm going to do is just, for now, what am I going to do? I think what I'm going to do is use the unit test like for, what do I want to do? I'm trying to think about whether I want to commit this or not. Ordinarily, I would never commit a test that's not parsing. Yeah, so maybe I won't do that. It wouldn't do any harm for me to commit it because it's not being run as part of the, you know, the CI build as part of the test script, but I think there's sort of a principle at stake here, which I would rather maintain. So I'm gonna use this, but I'm not gonna commit it until I've made it pass, basically. But I don't think that's going to be too difficult. William's asking, would Ruby standard library test unit stuff help here? I assume you're intentionally not using it. Yeah, it probably would, or I could use mini test, which is also part of the standard library. Um, yeah, I mean, I am intentionally not using it in as much as I know that that stuff exists. I'm not sure why. I mean, as you can see, I've barely written any unit tests, so I haven't really thought about this very much. I think when I started, it was probably the float. Oh no, it was probably the S expressions I wrote first, but um, yeah, maybe this better illustrates like why I haven't bothered picking up anything more useful is because like I didn't really need to. I just all I wanted was just to check a few things and raise exceptions, and like it was almost easier for me to do this than to go and you know to set this up as a mini test or as a test unit test and like remember how that stuff works and remember how to run them and stuff like that. So I've sort of started down this path of like, well, I'll just write a Ruby script that prints some green dots and raises an exception if the assertion fails. Maybe by the point I'm here, maybe I should just be using mini test or something. Yeah, I mean, certainly this S expression parser test is a bit silly. I probably should have used something for this rather than you can see that all I've done is like I wrote one test and then I just copied and pasted it and changed the input and the expected, and that's worked fine, but it's all a bit of a mess. So yeah, in summary, you're right. Test unit or mini test would definitely help here, and maybe I should, for the moment I'm going to carry on in this vein because this is what I've got elsewhere, but maybe there's, in fact, why don't I add that to my to-do list here. I mean, I've got a thing here that says set up rspec ? Or just use test unit or mini test for test star instead of copying and pasting print raise. So I'll add that to my extensive list of stuff that I should do at some point so that I don't forget about it. But for now, I'm just gonna continue plowing this lonely furrow of making a big mess. So okay, but I can at least run this, and it tells me that the thing's not doing what it's supposed to be doing. Don't really need that open anymore. So, how do I want to do this? I'm just thinking about what approach I want to take, because here, this parser has got some state. It keeps hold of the current S expression. Ultimately, it's sort of consuming that S expression. It uses shift and it sort of takes it to pieces as it parses it. And it knows that it's finished when the current S expression is completely empty. I'm wondering if for this preprocessor thing, might it be simpler? I'm just thinking about... I'm thinking about whether I can do this sort of, a little bit more declaratively using pattern matching and stuff like that. Unfortunately, pattern matching is not very good for this kind of thing. Like, it's not very... Like, for example, pattern matching doesn't give me an easy way to make this ID here optional. What I'm talking about is if I was treating this, well, like as in this test, here this global thing here is like, there's an array that's got a certain number of entries in it. So it's got global, and then it's got this import thing, and then it's got the global type here. I don't know how I'd write a single pattern that allows for there to be an optional ID in here. Or maybe if it's a find pattern, I could just have a sort of a splat that allows there to be an arbitrary number of things, but I don't think there's any way to say 0 or 1 things. But I mean, it's not very difficult to write two patterns, one with and one without, but it's just a little bit grotty. How do I want to do this? I'll maybe make a start just doing it sort of declaratively and see how far I can get. But like I say, I'm sort of anticipating that Ruby's pattern matching is not gonna give me what I want here. But anyway, here I can just say sExpression map do what are these called? Oh, command. Process command. So this is going to be either a module or something else. So I'm going to do how do I want to deal with this? Maybe it's just like something like that. Like, this is what I would like to do, is sort of build up. I mean, is that syntactically valid to just have an else? No, it's not. Well, unfortunately, I can't call that local variable module. Right, so that's okay. I mean, we're still not doing anything, but we're sort of drilling down to the point where we're able to process. Oh, and then these are fields inside a module, right? Where does it talk about the syntax of modules? Oh, maybe this is bottom up. Oh yeah, it doesn't explain anything here. But here, I think, in the text format, it will say a module consists of a sequence of fields that can occur in any order. So I can just say module or mod map do field process field. So really all I'm doing is just recursively mapping over, because this is what I want to get down to, is the point where I'm processing specifically a global field. And then here, I guess I can do in global puts found a global. Oh. Oh, right. Okay. So yeah, I wasn't thinking about this right. So when the command is a module, oh, thanks for joining, William. Wow, RubyConf New Orleans. Yeah, that was a while ago. But yeah, I'm glad we had a chance to meet. Thanks for stopping by. Please come to a future one. See you another one. Yeah, so I'd temporarily forgotten what the syntax of modules looks like, right? Because module is the first element, and then the fields are the rest of it. So I need to, maybe this needs to be case command in module splat fields. No, I think... I think probably something like this. Right? And then the return value is... So yeah, I think this is what I meant, that like if it starts with so we sort of switch to the right processor, and then the processor has to deal with like, well, what's the, in this case, the syntax of a module is that it's just the module keyword. Oh yeah, I have to deal with the optional ID. Did we establish that you can splat a nil? Yeah, because what I need to do here is, well, I won't worry about it yet, but I'm going to have to deal with the fact we're going to have to deal with the situation where there's a module ID in here. Oh, but in fact, we're going to have to deal with that immediately because this is currently hooked up to the interpreter. How do I want to deal with this? I'm just trying to think about the ordering of operations with respect to the tests and things failing and stuff like that, because at the moment I can't really do anything here that might break. Well, actually, I've just got to be... I don't want to break the acceptance test is my point. Sorry, I'm not being very articulate here. I've got to be a little bit careful here that whatever I implement allows everything to pass through unchanged except the specific thing that I'm looking for. And I think I can probably achieve that by not assuming that the field is necessarily an array. So here, if this becomes case field in global star, so I successfully found a global, but if I just return the field, so that preprocessor test, that unit test is still failing. Oh, and I've broken global WAST. Okay. Okay, what have I done? Okay, at what point did the acceptance test get broken? Okay, look, I don't know why I'm running these in two separate tabs, so I'm just gonna, for a moment, I'm gonna close one of those tabs so that I don't get confused. Okay, so the acceptance test is fine at the moment. So now process module. If this is just what I think is the identity, no matching pattern error. What is going on there? Oh, it's because this needs to be... okay, we'll get there in a minute. So this needs to be... this shouldn't be in a nested array. This needs to be... again, because this might... yeah, well, it was just wrong before. Okay. All right. So now... okay, we're getting somewhere. I'm hopeful that now... okay, that's all right. So I think I've managed to plumb this in a way that it is not touching. So what I had to worry about was the fact that them in the acceptance test, there are going to be places where IDs appear in these modules, and I just want to ignore that. And that's what I'm doing now, is that the else clause here, well, I mean, obviously this leaves it alone anyway, but it's important to have an else clause here that will be triggered in the case that it's not even an array here, that it is just an ID, which will just be a string on its own, not an array. Oh, and I guess I'm just returning field data anyway, aren't I? Okay. Well, I'm relatively convinced that that's not broken anything. So now I'm just going to think about what I want to happen here. Obviously, the unit test is going to still be failing because I haven't done anything yet. So if it's a global... so how do I want to do this? Do I actually want to look specifically for imports? Maybe I do. So let's look at that global syntax again. Like, what's the most liberal thing that I can write here? Like this... okay, I think I actually can do this with a pattern match, can't I? Because the ID here is just like... whatever. Like, I can use a find pattern here. So I can... so what I'm talking about here is that if I want to say global foo in global star ID name, then like name is going to be foo and ID is going to be nil. Whereas if I do global bar foo, then name is still foo, but now ID is going to be bar, well, array of bar. That's the only way I know of to make this optional, is to allow there to be an arbitrary number of elements here. But let's try that for now and see what happens. So this is global optional ID. And then there's going to be import. What did I call this in the AST parser? Import module name and import name. Well, I can just do module name, name. I don't need the import. And then global type. What can that look like? Oh, but it's, I don't care what it looks like. Like, I think this is what I need to do here, is like be willing to just make this, to just bind this to whatever appears at this point, right? So here, there's like, there might be, well, I mean, here I've said an arbitrary number of things. It can actually only be one thing or 0 things. And then this import, and then the global type. And if I get that, and only if I get that, are we going to then rewrite that to look like import module name name, and then a nested array that says global. We're gonna, if this was nil, then there's going to be nothing there. If it was a single element array, we're going to explode that single element array and just put that one ID element in. And then global type. Damn. Well, the good news is the unit test is passing. The bad news is the acceptance test is failing. So what have I done wrong there? Oh. I think there's a distinct possibility that I'm not importing global variables properly. Let's just check. Yeah, look, it doesn't check imports here. Let's just copy what I've done from somewhere else. I mean, I've chosen the one worst thing. It turns out this is the one place where I actually haven't implemented the top level. So this is going to need to be global imports plus globals.map. Which is what this code was. And then this is going to have to be global imports equals import select import in kind global, presumably. Let's see. Yeah, if it's global, then we do global here. So yeah, find a top level import whose kind is global. So I think what I've done here is to add support for explicit global imports in addition to what we previously had, which was just the inline imports. So that was a stupid one for me to check. Oh, unknown keyword imports. Oh. Wow. Oh, okay. That's still not working. Okay, well, perhaps this was just a bad choice because now I don't know why it's not working. Let's just see what build tables look like. So again, table imports, import select, import in kind table, and then this was all the same, and then global imports plus globals.map. If global import nil, make a new global, otherwise fetch it. Yeah, so that code looks right, but I don't think this has changed. This is the same error as before, right? Expected 666 got blah. Let's just see what happens here. All right, well, that's not very interesting because I can't tell which one of these is supposed to be imported. This, I think the test here is all to do with having references to the right global object, because it imports a global and then it sets it and then it reads it from somewhere else. And so, you know, this doesn't give me any information about which object is being pointed at. They're all just empty globals. I'm a little bit stuck. I don't really want to get into debugging this. I think I'm going to back out of doing anything with globals because I'd forgotten that they're the one thing that I haven't actually implemented explicit imports for. And I do need to do that. It's on my to-do list to do, but I don't want to get distracted by doing that. So why don't I just pick something? Let's see, what have I got? Basically, it's functions or tables. Maybe tables. The problem is that with tables, it looks like it's only explicit imports that are currently supported. Like, it doesn't look like there's any support for implicit imports here at all. So I think it's going to have to be functions because it looks like that's all I've got. Okay, so hold on. Let me stash all the changes I've made and just figure out where does this matter. So this is the support. What I've just commented out is the support for inline function imports. So who cares about that? Like, I just want to have an acceptance test that cares that I can keep parsing while I'm fiddling with this. I don't know why I needed to implement that in the first place. I don't know what test provoked that implementation. Come on, tests. Okay. All right. Well, apparently it's names.wast, which is not what I was expecting. So am I going to have func import? Yeah, okay. So I think maybe this was the only one, but clearly I needed, in order to get this test parsing, I needed to implement this, so I did. So, okay, well, now that I know that it's names.wast, I will change my example so now we're going to be running names.wast, currently parsing. But let's change this so that instead it's so what's this going to look like? Oops. This isn't really saving me any time, is it? Okay, look, forget it. Let's just do an IRB again. So I want to start out with that function definition. Excuse me. And I want to end up with, well, again, let's just confirm, but I think it's going to be the same kind of deal. I mean, even though the syntax is more complicated, I think for imports, it doesn't really change, right? So this func missing ID import spectest print i32 param i32, this is going to change to import spectest print i32 func missing ID anyway, and then type use. Yes, I think that's correct. Yeah, so again, it's just swizzling the order of, you know, we're sort of conserving all of the original keywords, we're just moving them around. So now that unit test should be failing again. So let's go back here and make this so that instead of, well, it occurs to me that it really doesn't matter whether this is global or func, right? But let's, for now, keep it focused on func. I mean, at least this bit is different. This is a type use. Oh. Why hasn't that? Did I get the unit test wrong? No, I don't think so. I think the type use is correct. So what's gone wrong here? So I was expecting module import spectest print i32, etc. Module import spectest print i32 func param i32. Oh, have I messed up my... Yes, I have. I've messed up my my parens. Okay, yeah. So that square bracket needs to be at the end there. So yeah, I did screw up the unit test. Okay. Oops. Okay, so that's where I wanted to get to, is that now the acceptance test is still passing, but I've got a unit test that won't pass without that change. Without this change to the preprocessor, basically. Oh, I mean, yeah, maybe I need to think about this a little bit, but just looking at this, it seems like it's going to be very easy to just make this a generic D sugar for all imports, basically, because really not very much varies here. Let's just have a quick look. Yeah, they all just have... You know, they've all got a single thing that appears after the ID. So it would be easy to make this general and make this work for func or table, for example. But I'm going to keep it specific for now. So I'm just going to think about, like, what do I actually want to do here? Well, firstly, let's make that new tab again so that I can just leave all the tests running in the background while I think about what I want to do here. Okay, yeah, I was just checking that I feel like there probably should be an underscore in type use, but I'm clearly not doing that yet. So this... What have I done here? I feel like this should probably... Oh, no, that's okay. It's really the first thing in the command that makes it interesting here. What can a command be? Module, register, invoke, get, assert. Yeah. What's the... Do fields have a common format though? I think they probably do. Begins with type, begins with import, begins with func, begins with table, begins with mem, begins with global, begins with export, begins with start, begins with LM, begins with data. Yeah, so all of these are, I think what I'm trying to get at here is that I think it's, oh no, but here we've got to tolerate. Okay, sorry, I'm thinking ahead. I'm trying to make this as explicit as possible as to what we're expecting to support here. And here I'm, this explicitly says that command has to be an array. I mean, is that true? Yes. Just for a moment there, I was like, well, because you can do that, but that's not what first does. So this is explicit about the fact that command is supposed to be an array. But here we're allowing fields to not be an array. But the only reason we're doing that is because there might be an ID. I think I'm going to leave this for now, and then I want to come back and make a change to this so that, so that this is case field dot first. And then we only, basically we need to extract the ID from the fields if it's present and not pass that ID into process field because we know that it's not a field is what I'm trying to get at there. But I can clean that up in a minute. Oh crap, something's broken. Is that broken because I was editing the file? No, I have actually broken something. Damn. Okay. Well, that's not good. Okay, well, I suppose I need to understand what's happened there then. Oh, that's very unfortunate. Okay, so what's going on in func pointers? Can I make a minimal? In fact, let's just do that. What is going wrong with func pointers? In parse index, unhandled exception. I think maybe the quickest way to understand this is just to cut this down a bit. Like, is it just during this module? Is the problem in there somewhere? Yes, it is. Okay. Is it... just that first line? No. Let's just uncomment these until I can see what the problem is. Okay, so that's all okay. Those are just one-line comments, so those shouldn't be problematic. Okay, so it really is just this last one. Because this is the one that's trying to call print. Okay, so if I comment out all of those and all of... those, but I need you. Is that a test that would otherwise have passed? No. Nil does not respond to deconstruct keys. Oh, okay, well this is type 6, which should now be 0 because I've removed all of these other types. Okay, so that's all right, but not with my preprocessor changes. Okay, so this is like the minimal reproduction of the problem that I'm having. Let's just have a look at what the preprocessor is turning this into. So what's happening when we... What the heck? That's not what I wanted. Okay, too many tabs again, sorry. So this func print import spectest print i32 has turned into import spectest print i32 func print type 0. That looks correct to me. Like it looks like the preprocessor has desugared that abbreviation correctly. Okay, so what's gone wrong? I mean, let's... Okay, I'm going to back this up. What I'm going to do is... manually desugar this. This is the bit that I'm desugaring. So I think that this should become import spectest, and then this should be func $print type 0. So firstly, let me just compare that to what I got here. Because obviously the brackets and stuff matter here. So used to be func, now it's import. Import spectest print i32. Func print type 0. Right, so I think this is all correct, right? The func has become an import, followed by the two names. So it's become import spectest print i32. That's correct. And then in brackets is func and then the ID and then the type use. So we've got func, we've got $print, and then we got the type use. So that all looks correct to me. But I'm assuming, yeah, so there's some different problem here. Okay. So it turns out that top level imports, in this case, don't work correctly. So this problem is independent of the preprocessor, right? Like I've got some kind of other problem. Something's going wrong in the parser. Okay, so I'm going to have to debug the parser. Like, I mean, I'm going to have to get to the bottom of this. Unhandled exception, line 932. So let's just at the top here. Parsing normal instruction as expression inspect. So it's the call $print. So I guess it's the $print that's been a problem. Index space for opcode is index space inspect. Index space for call is nil. So okay, well, I think I know what's happened then. I think that we are not populating the initial context with function identifiers from imports. Build initial context. To do, add imported function table global memory global name to context. So I think this is why the global one was failing, is because of this problem. But that was less obvious to me before because we didn't even have support for, in terms of operational semantics, we didn't have support for explicitly imported globals anyway. So I thought there was something wrong with that code. But actually, I think the code that I added for globals was probably fine because this is the problem. We're just ignoring... For the purposes of populating the initial identifier context, we're just ignoring imports, and that's a problem. So I'm not going to be able to desugar imports at all until I fix this. So I think I'm going to have to fix this. So fortunately, this is documented, I think, in here. How do we compute the initial context with respect to imports? So this thing here about populating the initial identifier context is just saying, like, based on all of the fields in the module, here is what we need to add into which index space in the identifier context. And you can see that if it's an import, then depending on the kind of the import, if there's an ID, then we have to wang it into the appropriate index space, into either funcs, tables, mems, or globals. So what's this going to look like? So import here. Oh, okay. So we're gonna be reading the syntax of import is that it's followed by the two names, right? It's so hard to navigate. Where's imports? Okay, import, name. These don't have any bearing. We only care about the import description. So we're going to read those two names and just ignore them because we don't care. And then we're going to read list. And it's either going to be func, table, memory, or global. I'm just remembering how read list works. Right, so whatever we return from the block is going to be the result, so that's fine. So somewhere inside here, we're going to make a new context, and it's going to be like this. It's going to be like index space name maps onto name, but we just need to like choose those things. So we know that it's going to be one of these four things. What is it? Do we call it kind? Yeah, read into kind. So I'm going to do the same thing there. I'm going to read into kind. And I suppose maybe it's useful. The reason I'm doing this pattern match thing is so that I can be explicit here about what we're allowing it to read at this point. So if we read anything other than those four supported kinds, we're going to get an exception. And then I can say index space name is equal to fetch kind. And this is just going to be so it is just literally the symbolized version of that. I mean, actually, there's no point in me I can literally just symbolize it, I think. And then we can optionally read a name if there is one. So if there is an ID here, so if the next thing we would read is going to be an ID, then we read it into the name. Otherwise, name is going to be nil at this point. And then we just return a new identifier context that maps that index space name, which actually happens to, I think, match. Oh, is that right? No, it's not right. I don't know why I thought I could do that. What am I confused about here? Oh, this is just this is the syntax of the, right, okay, this is what the AST looks like, but that's not the same. Okay, yeah, I was being silly. Okay, so I do need to do a mapping here. Okay, so how do we map the kind to the index space? Well, that is what this was telling us. So if the kind is func, then it needs to be functions. I mean, it's very similar to this. If the kind is table, then it needs to be tables. If the kind is memory, do we have a memory index space? Probably not, because there is only one. So we'll leave that one for now. And if it's global, then we're mapping it to globals. So if I haven't screwed that up, oh, apparently I have. Unhandled exception. So what's the problem? Is it this raise unless finished? Have I not finished? Why haven't I finished reading? Oh, right, because I need to read the rest of it. Okay, fair enough. Yeah, you have to throw away, after you've read the ID, you've got ... here, so whatever comes after that. I mean, there's only ever one thing, I think, but... Okay, great. So, okay. So that's added support for... Right. So yeah, that has... I've done this. I've added added support for imported explicit import names. They now get added to the initial context. So that now should mean that when the preprocessor is in place, oh, it was func pointers that was the problem. Okay, so I think that's okay now. So I don't need my local copy of func pointers anymore because the real one is now parsing. So let me run all the tests. So, well, hold on. Let's take it. Let's take it a step at a time. So I've added a capability to the AST parser, which is to populate that top level, that initial context. if I run all the tests, having just made this change, I want to see that that doesn't break anything. I'm just thinking about whether I can structure this differently, but I don't think I need to. It's like, could I have read list return something? But no, not really, because the things that you read are inside the list. I could put them in an array, and a 2-element array, and return them, but there's just no point in doing that. Oh no, something else is broken. Crap. Key not found memory. Yeah, good point. Good point. So it turns out I can't ignore that. Import spectest memory, memory1. So yeah, I mean, this is all a bit of a... It's all a bit of a game because you can only have one memory. So the whole notion of having an identifier space for storing the IDs of memories is a bit silly. Memory definitions combined a symbolic memory identifier. I'm not sure. I mean, I hope I'm not imagining that about memories. Yeah, in the current version of WebAssembly, the only valid memory index is 0, or a symbolic memory identifier resolving to the same value. So the memory index space is a bit of a joke, but I think maybe I should just introduce one for completeness sake. Because what I want to be able to do here is for memory to map onto, like, whatever it wants to call it, memories or something. Mems. But then that's going to have a different error where it's going to say, I can't, there is no thing called mems, unknown keyword mems. Identifier context. Do these have some kind of order? Types, funcs, tables, globals. Yeah, so mems should be in here. So I've introduced that just to shut this test up. So now we're a couple of recursive layers down the rabbit hole, but I think this... So actually, you can see that this data.wast, even though it doesn't appear to contain a single assertion that we support, nonetheless, just being able to parse it successfully is actually testing something useful, which is like, are we populating the identifier context correctly based on what's in the syntax? And I mean, all of the pain I'm feeling at the moment is because of how ad hoc the implementation is at the moment. And this is exactly why I want this pre-processing step to be in there, so that I can do all of the desugaring up front and then make both the AST parser and the interpreter much more regular in their implementation. But I've got to work my way up to it, unfortunately. So if these tests all pass, then I can add the thing that populates the initial identifier context from the imports. And if the tests all pass, then I can start doing the desugaring. And I will do functions because I know all the pieces are in place for that. But then I think I should go back and do what I did with the globals. Because I think the code I added to the interpreter was probably correct, and the reason why it wasn't working was because of this initial identifier context thing. Okay, so the tests are all passing, so now I can finally make a commit that says something like, yeah, so this is just like add memory index space to identifier context. And I think it will be worth saying I want to link to that. Wherever it was. Oh yeah, okay. This thing. Yeah, so that's really the only place that it says that the only valid memory index, that's really only mentioned here. I mean, maybe I'm wrong. Yeah, I'll try and explain that here. The spec says that the only valid memory index for a data segment is 0. But that doesn't necessarily mean that only a single memory declaration is allowed. Only that that the first one must always be the what, the target? Yeah, of an active data segment. Still, I suspect there's no practical use for the memory index space. I'm adding it anyway, since it makes the rest of the implementation more regular, specifically the population of the initial identifier context from explicit import fields. Okay. So yeah, I guess this is what I wanted to say, is that just because I got the idea in my head that you were only allowed to have one memory, but I realize now that I had perhaps been overly... This doesn't actually say that. This just says the only valid memory index is 0, and that's specifically within the context of defining a data segment. This doesn't necessarily restrict, and in fact there is no explicit restriction on how many of these memories you can declare. Like, I don't think there's anything that says you can only have one of these. In fact, maybe there's a... See, like, all of those modules only have one memory in them. I don't think I've seen... It's only got one memory in it. I don't think I've seen a module that has more than one memory in it. And maybe the operational semantics restrict this and say, you know, that in the current version of WebAssembly, during module instantiation, you're only allowed one memory or something. But it's not explicit in this. It's not syntactically constrained. So for syntactic purposes, I think it makes total sense for me to keep track of these memory identifiers here. Even though in practice, we don't really need them. Okay, so like I said, now, and let's just run the tests again, but now this is the thing that adds, this is the to-do, right? And it's probably in here somewhere. Well, this was the thing that I need to do to desugar inline imports for globals. Yeah, this is the thing. Per the spec, make sure that import func foo adds foo to the function's index space of the identified context. Ditto for globals, memories, tables. So that's what this does. So I'm kind of preemptively checking that on the assumption that I'm going to be committing that now. So this is going to be something like this. Add imported function table memory global names to initial identifier context. Yeah, okay, so that's all okay. I don't really need to say more than that, you know, because there was already a to-do here, so this clearly needed to be done, but I'm going to say this has finally been motivated by the desire to desugar imports before, well, desugar inline imports into explicit import fields by the preprocessor, so that the AST parser only needs to deal with, well, explicit import fields. I don't need that parenthetical aside. That's only possible if the identifiers from the inline imports, oh dear, remain present in the initial context once desugared. And for that to happen, we need to correctly populate them during the build initial context method. Okay, great. So now, finally, I can do the desugaring without breaking anything. What's happened to the parser? Right, yes, okay. Good. Okay. So this is now desugaring inline function imports. And I think I've got a unit test that proves that we're doing that. So let's just walk through this slowly. If I add the unit test only, it is failing. If I add in the preprocessor as well, it is parsing. So that change to the preprocessor is making the unit test pass. And now I hope to be confident that it's not breaking any of the acceptance tests. So let's preemptively write a commit here on the assumption that it's going to work. Actually, while that is running, let's make this a bit less annoying. Well, maybe I'll just write it myself. So this is going to be something like module func import spectest print i32 param i32. It's like that. I might as well use square brackets because I need to put square brackets around it, because this is supposed to be an array inside an array. Okay, let me just think about this. There really is no nice way to write this. Okay, well look. This can certainly that is an array of strings. This is an array of strings. So that's okay. Okay, good. All of the acceptance tests pass. I mean, this isn't super important. It would just be nice if there was an easy way to do this. And I realize I could just use the S expression parser, but I'd rather not. Maybe this is the least annoying way to do it. Like, I'm not doing anything clever. I'm just taking advantage of word lists, like where they're convenient, and getting rid of double quotes as well. So I guess this is the same kind of deal, isn't it? Is that I could write this as the slightly nicer hold on. Oh yeah, except this. Oh God. So this needs to be, oh, this isn't really nicer, is it? Maybe that's okay. It's just a bit of a mess. Yeah, maybe that's okay. Because it's sort of inherently, this does actually show you that what it's doing is sort of inherently flattening it out. Yeah, maybe that's okay. I think that this is slightly less, for me at least, this is slightly less hard to understand than what was there before. Okay, so this is in fact, why don't I, one of the things that I've implicitly been thinking about here, but that isn't represented by this, is that we need to support identifiers. So here it's important that if this is called my module, that needs to be preserved here. And I think that that is going to work. Yes. Likewise, well, let's copy this one. Same for the function. Like if this function is called my function, I think that has to be preserved here. Also very important. So I think we need those three test cases to prove that identifiers are being preserved, because this is very important for the acceptance tests that we leave these alone, even though for the specific case I was thinking about, it actually didn't have it had neither a module nor a function identifier, but it's really important that they get preserved by this transformation. So I'll have those in the unit test as well. So I think this is just going to be expand inline function imports in preprocessor. Abbreviations. Or should it be desugar? No, I think I'm pairing the words expand and abbreviations here. So I'm expanding an abbreviation, and the kind that I'm expanding is the inline function import abbreviation in preprocessor. It's important that this abbreviation respects both module and function identifiers, so they are explicit tests for both of these. So I think maybe I can get away with so maybe there's like, unless ID in some kind of array, sorry, what am I talking about? What I want to do is check to see whether the first element of fields is a string, I suppose. Well, in fact, can I just do fields in? Yeah, hold on. Let's say that I've got A, B, C in, well, let's say fields is equal to that. And then I see fields in a string called ID, and then the rest of it is fields. ID is going to be nil, and fields is going to be what I started with. Whereas if fields is module, my module, and then I say now ID is going to be my module and fields is going to be the rest of it. So yeah, I think I can just do this with a pattern match. I can do fields in a string called ID and the rest of fields, and then yeah, okay. So I can splat it like that, whereas if fields is this, That does nothing. Oh, well. Let's reset the local variables. That does nothing, and then now if I splat this, the ID has gone away. Yeah, that's what I want. So here is like there's an opportunity for, if there is a string at the beginning, for it to be pulled out and preserved there. And then do I care about the same thing happening here? Like, do I need to handle this explicitly, or is this okay? I think maybe this is fine. Like, all I've achieved by that change is the essentially invisible constraint of process field no longer gets called with an ID. It only gets called with an actual field, which isn't really very important. But I think maybe that's an improvement on what I was doing before. It makes it easier to understand. Well, I think it was weird before that process field was being called with something that's not a field, right? So the fact that there's an optional ID here is being dealt with at this point. Yeah. Okay. I think this is all right. I'm gonna commit this. Deal with module ID explicitly. Well, let's say separate module ID from genuine fields in process module. This doesn't change the behavior. It just makes it easier to understand the circumstances under which process field is called, i.e. only for actual fields, not for the module ID. Yeah, I mean, I'm trying to think about No, I think this is fine. I was trying to think about whether there's a sort of a more general way of doing this that doesn't need to know the details of the syntax, because really this desugaring can be pretty relaxed, I think, but the syntax is the string module, possibly an ID, and then a list of module fields, and then that's sort of explicitly what this is saying. So I think this is probably the right amount of relaxation. We don't want too much. If you get too relaxed, bad things can happen. So, okay. So now I've got the bones of this desugaring working. I think I have to make a decision about desugaring other kinds of implicit import of inline import, right? Because there's table, memory, and global as well. So maybe what I'll do is I'll add support for those individually without breaking things. And then I can consolidate them into a single implementation here, I think. But let's do them incrementally. So the next one would be table. So it looks like table, again, optional ID. And then import module name and name, table type. Yep, same business. And it's just going to be this, right? So I think the reason for me to do this in pieces, well, firstly, let's test it here. So what am I expecting here? This is going to be, let's look for an actual example. So this is from table.wast. Yeah, let's do that. So this is saying module table import spectest table and then this is slightly different. It's 0 funcref because table type is limits. So there's a little bit more, there's more variety here because limits can be 1 or 2 numbers and then the ref type can be funcref or externref. So actually the code I wrote here isn't right because it's not just one thing. Yeah, this, you know, it's not super regular, but grammatically it's totally legit. It's just that for functions, there was one value here that was sort of a nested array, a nested list. And here it's not nested, it's sort of top level. So we would expect this to desugar to, again, a sort of a flat situation here. So we'd expect this to say module table, and then this here would be table, no ID, but we would expect this to be a flat 0 funcref. So that's failing at the moment, and actually I think even with this implementation it's going to fail because that doesn't cover it. Okay. So I think that's, I mean, that turns it into a find pattern, but I think that's going to be okay. Oh no, it's not okay. Oh, damn. Okay. Okay, so how am I going to handle this? Because I don't know how many, this table type here can be 2 or 3. Because it's either 1 limit and a ref type or 2 and a ref type. But really, I think for the purpose of expanding the abbreviation, I just want it to be I think I'm going to have to be more. I think I'm going to have to be more careful about this. Let's just stash for a second and go back to this. Like, okay. So yeah, I mean, this is going to be a little bit tricky. Like I said, I think I got a little bit of a free ride there with pattern matching, but I think now I've come to the end of where pattern matching is particularly suitable for this purpose, because I think really what I need to do here is to be more explicit about it. I think this needs to be more like case field first. This needs to be more like in func. And then this needs to be a bit more like well, maybe it's like field in func rest, and then this is more like rest in id rest. And then this is like case rest in this business. I'm getting ahead of myself. Something like that, where we're like being way more explicit about destructuring this a piece at a time, so that when I want to do this for a different kind of thing, it doesn't, I could have, what I wanted to be able to put here was like splat table type. basically. Let's just see. I mean, does what I've written there even make sense? Yeah, I think it does. I mean, I think what I've written here must have broken must have broken the acceptance tests. Because I haven't put in an else clause. Yeah, instantly broken. So there needs to be an else field here. So it's not very beautiful because I need this sort of, I need to insert this here. To support the optional ID, basically. Whether there's a tidier way, because really we are just shuffling the parts of this array around, but it's like, it's a little bit complicated because we've got to, in order to decide whether we want to do it, we have to spot that there's this import here. So even though this is a bit clumsy, I think I do have to do something like this. Okay, well, on the assumption that that's going to pass, let's say deconstruct field incrementally in process field, and I'll explain that in more detail now. In general, this single pattern match approach isn't going to work for other kinds of inline import, e.g. tables, because there may be a variable number of elements after a variable number of list elements after the import clause, and Ruby pattern matching doesn't give us an easy way to express that. By taking the array apart in several pieces, we can be more specific about what we're expecting to see in each part of the abbreviation. Okay. Yeah, so unsurprisingly, that was a bit of a mess. So what would this look like? And like I say, I think these are fairly straightforwardly going to be combined into one, but let's just keep it separate for now. So table ID, import module name, and then yeah, the difference here is that this is table type, and that will be fine, I think. Oh. module table. Oh, I've still got a func in there. That's not right. Okay, so this should be table. Okay, cool. And yeah, am I confident that this isn't going to break anything? Depends on what the situation with tables and imports is. Although, did I maybe say that I already didn't have any support for inline table imports? Maybe. So it might be that this isn't touching anything as far as the acceptance test is concerned. Which is fine with me. I just want this to be working. Okay, that seems to all be parsing. So let's say expand inline table import abbreviations in preprocessor. And actually, let's just check. Yeah, it does look very much as though we never supported inline imports anyway, so I will just note that. It looks as though we never supported inline table imports anyway, but the spec requires us to do so. And this new unit test checks that the preprocessor is able to desugar them into already supported explicit import fields. It's fairly obvious that we're going to want to combine the func and table clauses in process field, but I'll do that separately. Okay. Maybe I'll just churn through and do the rest of these to avoid sort of speculative abstraction there. Because there's all sorts of other things that could potentially go wrong. So, memory. So this is going to potentially be a mem type. So let's go for something like this. We haven't actually, that test is not actually passing yet, but nonetheless. So this is going to be module memory import spectest memory 0, 1. Well, 1, 2. Okay, and that needs to desugar into, it's the same thing again, isn't it? Module import spectest memory, and then nested memory optional ID, and then whatever was there. Okay, so that test fails. Let's make it parse. So this is going to be memory. This is going to be memory. And instead of table type, this is mem type. All right. And again, just let that run while I'm faffing about with this. Again, I really don't know what, if any, support we had for memory imports, to be honest. No. Doesn't look like that was ever a thing. And in fact, I don't know if we've got any support for explicit memory imports either. Let's have a look. Oh no. So we do support explicit imports, but just not, we don't support the inline ones. So this is just going to be pretty much the same as this one. Expand inline memory import abbreviations in preprocessor. So I'll just say, you know, as with inline table imports. Well, I'll just let this finish, but no, there's no, I think there's no chance of this actually breaking any of the tests. So we say, oops, sorry, Etienne. As with inline table imports, we don't actually support these yet. So the expansion of the abbreviation doesn't affect any of the currently parsing tests. Okay, well, we're nearly done then. Well, he says. We just want to do, excuse me, we just want to do globals. So let's do that. And when I say do that, I mean write a test and watch it fail. I mean, do I still have, back in the mists of time, I had a global here, right? So I do sort of have this already, but it's just going to be a bit annoying to convert it to this syntax. So let's just copy what we had here. So module, global, import spectest, global i32, and then this should just be i32. And then this looks like module, import spectest, global i32, global, oh well, this can be so hopefully that test is failing. Yep. Now this can be global This is global, and instead of mem type, it's global type. And what does that actually look like? Oh, right, it can be one of two things. But I think that is fine. I think that's probably what I did originally when I first tried to introduce this abbreviation. So that's fine. Now I think this is probably going to break because of the thing, because of the lack of support for explicit global imports. So I'm expecting to get a problem here. So I'm going to need to drop in a commit that adds support for explicit global imports first. But let's just watch it fail, and more importantly, tell me the test that cares about this, because I've already forgotten which one it was. There we go, global.wast. Okay. Great. Okay, so this failure is useful because this is going to allow me to know whether I've actually done the thing I wanted to do. So I think it was here, wasn't it? I could just, let's nick this. Global imports, kind, global. And then this just becomes global imports plus. So now we're finding the explicit imports, and then we're adding in the inline imports. And obviously what I'm hoping for is that we're going to be able to get rid of this, but not yet. Oh, yes, okay, fine. I forgot about this. Oh, rubbish. Okay, well, I guess I am actually going to have to debug this now, aren't I? Oh, that's what I was hoping I could avoid. Oh, look. This is irrelevant, but look, there's... Look, there's... I should have cleaned this up when I added in the... In fact, why don't I just do that while I notice it? Yeah, I mean, it was called mems in the end. Do I have any more to-dos related to that? No. Okay, let's... So yeah, backing out of that whole... Sorry, I got distracted by this, but I should have done this earlier. do I want to squash this into the earlier commit? Well, let's see if all the tests pass, but if they do, yeah, maybe I will just squash it into this one, because it's such a trivial change and it's sort of unlocked by this. No, I'll keep it separate. Oh look, it's actually broken something. Oh no. Okay, well I think the problem here, okay, well it's a good job I didn't just squash this into that previous commit. So I expect that the problem is that when we parse memory, we don't do anything with the, yeah, we just throw the ID away. More specifically, it's here, isn't it? Like when we build the initial context. So here we've got func table global lm data, and it should have memory in it as well, because if memory starts with an ID, then it needs to go into the mems. So I think that that's going to fix this problem. Yes. Okay, well, in that, you know, it clearly did need to be a separate commit. Excuse me. So yeah, potentially even two changes here. One of them is to add, you know, I did the work to add imported memory IDs here to the mems index space, but I didn't do the work to add just normal memory IDs to the mems index space. So this is something like add normal memory IDs to initial identifier context. I'll say in this commit, I did the work to add imported, well, this instead of normal, it's say non-imported memory IDs to the initial context, but forgot that we also need to do this for non-imported memories, so that all the memory IDs are available in the identifier context. Yeah. And then I can do this. Use memory index space to parse memory IDs. Okay. All right. So everything's working now. What was I trying to do? Right. Okay. So this was failing for a different reason, not to do with memory, I think. Oops. Exports. Oh, but maybe that was... I'm just... My brain's not working properly, I'm sorry. I think that was the one that I broke with the memory situation. So is it global.wast? Yes, okay. Okay, well, just out of interest, because, you know, I'm changing two things here. Excuse me. So is just adding this okay? Yes. So that doesn't break anything. And in fact, I think this is extremely likely to be correct. And in fact, I think I'm going to commit this because I'm pretty sure it is correct. And up until now, I've been reluctant to make this change because I didn't have a failing test for it, but now I sort of do. Well, except the problem is that it's not really what I meant by a failing test. Like, why? I sort of wanted it to be the other way around. I wanted it to be that when I added this so that we desugared the inline import, well, what I wanted was for it to be causing a test to fail, and then when I made that change in the interpreter, for the test to be parsing again, but actually the test is not parsing. So that doesn't fix anything. Before I commit anything, maybe I'll try to just understand this a little bit better. So again, I'll do this maneuver where I'm going to copy global.wast to here. I mean, it's the very first assertion that's failing. So how easy is that to pin down? So if I just put that assertion there. Okay, it still fails. What is this referencing? Get a. Can I just remove all of that? I mean, of course, you know, what I want is for it to be failing in the same way, which it does appear to be. Okay. So this is just expecting to get the global A, which is defined there. I mean, it's weird, isn't it? Because this doesn't seem to have anything to do with the import. Wrong flipping tab again. Okay, so that's... Okay. Um, so it does look to me as though so what is this actually getting? Because I think when I removed those, got nil. So is it actually getting the value of some other? Ugh. Yes, okay. So this thing here must be -4. Oh, I can't remember enough about... At one point, I would have been easily able to verify that that was -4, but I've sort of forgotten how to do that. Maybe I can do it. Is that like a decode method? Oh, right. And what was it? This would be a 64-bit, so where's my format? Float, format, double. Oh yeah, -4. Okay, well, there we go. Confirmed. Okay, so that's... So what's gone wrong here? This $A used to refer to this global, but now it's referring to this global. So, yeah, okay, that makes sense. I understand. Because you know, I've prepended. If there are explicit imports now, I've prepended them to the list of globals. I mean, I'm not sure why that's resulted in pushing it forward. I sort of would have expected it to go in the other direction, but so maybe I don't understand it. So let's say building globals, imports, imports.inspect, globals, globals.inspect. I just want to try and get my head around what's going on here. Just going to close that tab. So there should be 2 imports. So this should be desugared into there being 2 imports. In fact, why don't we let's look at the whole module as well. So as a module, the functions are, there's one called getA, no import. Can I use pp here? Yes, okay, that's a little bit easier. So there's one function, globals. So those imports look correct, but what's going on with the globals here? Just 3 of them. So there should be a 32-bit -2, a 32-bit float, and a 64-bit float, integer, float, float. Yeah, that looks all okay. That looks like -2 to me. You know, in 2's complement in the 32-bit. So what's gone wrong with the function definition? Get the global with index 2. Well, that's right as well. And yet somehow it's reaching into... Oh, is it initialize globals that's gone wrong? Yeah, it probably is. Right, the sort of, it's the each with index problem. Right, so I think this is the problem, is that it's referring to the correct global. If global import nil. Right, if it's not an imported global. Right, okay. So now I do understand what's happening, which is that I think all of the globals are being created correctly, but then when we go to... Basically, these aren't globals anymore, you know, syntactically. These just become imports. Yeah, I'm having trouble explaining it coherently, but I think what's happening is that no, well, the reason I'm failing to explain it coherently is that I don't really understand it. Oh, yeah, look, okay. Yeah, this is the problem, is that we're only iterating over the globals. This mod.globals are the, like, explicitly defined globals, not including imports. So because these two are no longer globals, they just turn into imports, we're just iterating over these ones. and evaluating their initializer expressions. And then we're saying, well, this is global number 0, this is global number 1, this is global number 2, and we're assigning these expressions to global 0, global 1, global 2. But those aren't the right indexes for these globals because of the imports that come before them. So that's annoying. Why do we need to... Why is it important that we build the globals at this point? I can't really remember. I mean, I know why we're doing this after the module's been created, is because we need to have a current module to be able to, because all three of these involve evaluation, we need to have a current module. But I'm not sure. Apart from the fact that module is data, so we can't mutate it. But like, that's a choice, isn't it? We can decide whether module is mutable or not. And at the moment, it feels like the reason why we build all this stuff up front is just so that we don't have to, just so that we've got an object, so that we've got an array of globals here, even though none of them have actually been initialized, so that we can then iterate over them and initialize them. But I think for this to work correctly, it has to know the proper indexes, and at the moment it doesn't. So there's a sort of crappy way of doing this, which is to say, we retain awareness of the imports at this point, because that's the only way that we can know the correct indexes of these, right? Like, these come after well, let's see, where can I sort of want to find this so that I can, sorry, I'm not even finishing my sentences. There's something in the specification about the fact that all of the imported whatevers come before the explicit whatevers. So I think regardless of the order that these appear in, all of the imported globals kind of go at the beginning, and then the indexes start after the imported ones. I think that's right. But where would that be written down? Right, here we go. All imports must occur before any regular definition of a function table, memory, or global, thereby maintaining the ordering of the respective index spaces. So actually, it's not syntactically okay to put imports later. So I guess that has to apply to inline imports, doesn't it? Like, because this is just syntactic sugar for an explicit import. Yeah. This doesn't count as a global, like for the purposes of this. Like, it counts as an import. Yeah, okay. So what I'm getting at here is that to compute the correct, to refer to the correct global when we're initializing these globals, we need to we need to account for how many imported globals there are, because in this case these are going to be globals 0 and 1, and then these three need to be 2, 3, and 4. So when we're initializing the globals, we need to write these, we need to evaluate these expressions and then write them into globals 2, 3, and 4, not globals 0, 1, and 2, which is currently what's happening. Which is why this -4 is getting written into the value of this global A. So what I was going to do here, or what I started doing, was just passing in the imports here, so that initialized globals was able to count them and use that as the initial index rather than just starting from 0. So did we already have to do this anywhere? Maybe not. So maybe it's just that we have to count. We have to count how many global imports there are. Maybe this is global imports count. And then we have to add it on like that, so that when we're slicing the value out of the current module's globals, we're skipping over all of the imported ones, because it's only the explicitly declared ones that even have these initializer expressions. This is pretty clumsy, but does it fix the problem? Well, apparently. Okay. Um, so I'm just trying to think. Yeah, I mean, I guess I got what I wanted, which was that it was failing when I was expanding that abbreviation, because it turns out we actually weren't supporting imported globals properly at all, which is what this fixes. I don't need that global.wast anymore. So yeah, this is a bit of a mess. I think maybe it would be better if like it obviously clearly it matters what order we do things in during module instantiation, but like the spec will explain that, and at the moment I'm a bit worried that I'm having to do a hack like this to account for the fact that the globals are getting, the sort of runtime representation of the globals are getting set up, and like really this is the point at which we should be trying to initialize the ones that we're making, i.e. these ones, but it only gets done later, and in order to do it correctly we have to sort of recreate the correct indexes for them, whereas we knew the correct indexes well, we didn't need the indexes at this point because we're creating them right now. The only reason we need indexes is so that we can retrieve the correct instance of this global class, and we could have just assigned it at the right time. So I think that needs cleaning up later, basically. So I'm gonna add something like combine build globals and initialize globals, so that we don't have to count the global imports just to find the correct index of which global to initialize. This is probably all happening because module is immutable, but it doesn't need to be. Just look at what order the spec says the various parts of the module should be assembled during instantiation, and do that. Mutation and all. Okay, so that's something for me to sort out later, but at this stage I can just say add support for imported globals, I suppose. Yeah, this is it, right? Populate module.globals with both imported and defined globals during module instantiation. Yeah, let's just say support explicitly imported globals. Well, let's not just support, let's say include explicitly imported globals during module instantiation. And I'll just say this hasn't happened before because we didn't have a failing test for it. But now that we're trying to desugar inline global imports into explicit import what does the syntax look like? Well, I'll just say what it says here. The acceptance tests will fail unless we have proper support for imported globals. The implementation of initialize globals needed to be hacked to incorporate the count of imported globals when computing the index of which global to assign, or which global to initialize. This problem would go away if we were just assigning the initial, if we were just assigning initial values at the same time as we created the globals, which we aren't doing, which we currently aren't doing for the sake of letting module be a data object rather than a struct. That doesn't, there's no real reason for it to be immutable if we in fact need, well, provided we in fact need it to be mutable. We do in fact have some use for it to be mutable, so we should probably just change this and make the code simpler. Okay. All right, what was I trying to do? Right. I was trying to de-sugar the imports of globals. So now what's this called? Preprocessor test. Now that is passing. I'll run all the acceptance tests, but assuming they pass, this is going to be expand inline global import abbreviations in preprocessor. And I'll say something about this is possible now that the interpreter supports them or something. So this is done now. I mean, we've basically done this now. Implement the func oh no, that's export. Okay, not import. Okay, unfortunate. Because that, I mean, I guess that's the next thing I can do is to look at doing the same thing with exports, but this is actually a rather nice route into this, because it cuts across a few different, you know, there are those 4 different kinds of import. So like, and it's taken me a bit of wrangling to get all four of those working without breaking anything. But now that I've got all four of these working, and the next thing I'll do is consolidate them. The sort of the final step is to flush all of the, now there's like a load of sort of legacy code that is expecting at least some of these. Maybe it was just func and global to have support for inline imports, and so I can just remove all of the code that talks about that. So let's say this is possible now that the interpreter properly supports imported globals. Let's say explicitly. Okay. So let's combine these. Like this can be func or table or memory or global. And then we just have to remember that in kind is what I've called it elsewhere. So I'll just get rid of all of that. And then I think instead of type use, I think I'll just call this description. And well, so I think it has to be splatted because, yeah, because when it's like 0 and funcref, so that still works. And I'll just run the acceptance test. But I think that's sort of okay. I'm just wondering whether there's a nice way for me to it's so frustrating that you can't, like, what I want to be able to do here is have two alternatives. Like one of them here has got a string called ID and the other one doesn't. So like, if there's not an ID, so sorry, what I'm talking about is having a sort of an alternative here. But you're not allowed to do that because you're not allowed to bind kind and rest on both sides of an alternation like that. Oh, hold on. Oh, I just didn't save it. Why is that? Hold on, that's not the error I was expecting. I wasn't expecting a... I should be able to alternate. Right, okay, yeah, that's what I was expecting. Duplicated variable name. Well, okay, well, let's stop messing around with that for a second, because the test's all passed. So let's make this consolidate the 4 kinds of inline import in process field. And I don't think there's very much to say about that. Like, I've sort of done all of these separately and then demonstrated there's just a single way to smush them all together like that. I'm just wondering, like, the sort of the double else bothers me here. You know, you really just want to have a single fall through if. So is there a way that I can write a pattern here that will succeed? So if I don't worry about binding stuff, I mean, I guess I can always bind kind. Yeah, the problem is there's no way to... Okay, so I guess this is what it would look like, right? Is that you've got to match the kind there. There's a string. And then there's an import. And a description. Or you've got just func table memory global no string and an import else field. Module nil. Right. So that pattern match did succeed. It's just really frustrating that I'm not allowed to bind any I'm not allowed to bind any variables here. But this does at least detect the two this detects when we want to do something and then there's only one else. And now I guess it's like field. Yeah, this is what it would be like, isn't it? It's like, well, I don't really need to do this anymore because and then we don't need a case here. Like rest would be rest in import module name, and then this wouldn't be rest anymore, this would be description. And then it's just that, it's sort of unconditional. Oh, wait. Yeah, this is optional, isn't it? Yeah, so I guess what I'm saying is that this becomes like this. So we know that the kind is at the beginning. Then there's an optional ID. And then we know that the rest of it has to look like this. Yeah. Don't love it. Don't love it. Hi, Lane. Yeah, it is late. It's midnight right now. But I don't want to go to sleep until I have finished wrestling with this pattern match. I'm also a little confused about my white space options here. Oh yeah, that's okay. So I don't know how to nicely format this pattern, to be honest. Maybe I'm not allowed to do that? Oh no, I am. So what did I do wrong before? Maybe what I did wrong was like putting this on its own line. Yeah, that's not allowed. And I mean, this isn't great, is it? I mean, I guess I could do this, couldn't I? Like, if I'm prepared to let go of being explicit about the fact that you're only allowed. Oh no, see that's not allowed. Too many. Yeah, you're not allowed to have multiple asterisks inside. You know, you can have one at the beginning and one at the end, basically, but you can't have. I think, like, that's my understanding. I don't. It doesn't really make any sense to me, because what's the difference? I understand why you can't have 3 asterisks, but like, if you're allowed 2 to make it a find pattern, then why does it matter whether they're at the beginning and the end? I don't understand, but that's how it currently works. Oh, okay. Lane says, I'm more of a Python guy than a Ruby guy, so I don't know much about Ruby. Well, in a lot of ways, Ruby's pretty similar to Python. Of course, there's the sort of, you know, tyranny of small differences or whatever, where obviously every tiny thing that's different is something that people love to argue about. I actually don't know what the state of the art is with pattern matching in Python, but what I'm wrestling with at the moment is trying to match 2 different kinds of array that are very similar, except one of them's got a string in it that's optional, so it's either there or it isn't, and I'm trying to see if there's a better way of dealing with that than what I've just done here, but I don't know that there necessarily is. I mean, I suppose the alternative here is to just have 2 clauses for it. Is to just break this out and say, effectively, screw it, we're going to do this twice. And this one is literally like kind, ID, and this one just doesn't have the ID. And then we don't need to splat this, because it's either there or it isn't. Is that better? And in fact, look, so now I can actually do this up here. I mean, maybe I don't need to specify that this is a string. I can just say there is an ID. I mean, maybe it's easier if maybe it's clearer if I do say that, but I don't actually need to. Like, this is what we support. And then this is star description. And this one is the same. There's just no ID. I mean, I think although this has got a bit of duplication, I think maybe this is much easier to understand than the direction I was going in there, where it's sort of trying to make a sort of Frankenstein's monster of one big thing that somehow works. Like in this case, there are two different situations you can be in here, and the repetition, I think, is just inherent in the way that Ruby pattern matching works. But I think maybe this is better now that I look at it. Because we really do want to simultaneously, we're matching the presence of a kind at the beginning here and the presence of an import here, and they may or may not be separated by an ID, but like it's the combination of the import and one of these specific field kinds that drops us into anything other than falling through to just leaving it untouched. Lane agrees. Thanks, Lane. Okay, well, I'll do it like that then. If the audience approves, then why should I argue? So I think, even though in some ways it's certainly more repetitive than what I had before, I also think it's clearer than what I was doing here, because this is a weird combination of, you know, basically incrementally destructuring this thing, and I don't know. It relies very much on the semantics of this being an optional match, and then like understanding what the semantics of, this is undefined behavior as well. Like what happens to local variables if the pattern match fails, and I shouldn't be relying on this, actually, now that I think about it. So, because at the moment MRI will not reassign rest here if this pattern match fails, but that's not part of the specification of pattern matching. It's just an incidental detail of how it's currently implemented. So I think the sort of double else here, and the reliance on undefined behavior here, and the nuance of this being an optional match, it all adds up to a big smelly mess. Whereas here I feel like, okay, there's some duplication, but everything is totally kosher and it makes sense. So I think that's probably, for this project, that's the right way to go. So let me just write a commit there. Use 2 explicit pattern matches to deal with optional ID in process field. Oh, sorry, Etienne. I keep forgetting to put edit on the end. Although this introduces some repetition, I think it's clearer and avoids relying upon undefined behavior of pattern matching, i.e. The rest local does not get reassigned if the in match fails, which is what MRI currently does, but isn't part of the pattern matching specification of Ruby's pattern matching specification. And the subtle semantics of incrementally destructuring an array with a combination of blah and in. It would be really nice if Ruby's pattern matching had better support for this kind of thing, either by allowing allowing the same variable to be bound on both sides of an alternative pattern, or by explicitly supporting the idea of this array pattern. This element of an array pattern is optional. But it doesn't yet. So for now, I think the duplication is the least bad option. Because I'm prioritizing clarity over concision. Concision and cleverness. Okay, fine, done. Lane says, my mantra is, if it works, it works. Well, I mean, you can't argue with the tautology, can you? It is what it is. All right, words to live by. Okay, so I have now... Let's just take a second to take stock. See, I'm still... Of course, I'm still doing the same thing up here. I think for now, I am going to be explicit about that ID being a string. I think maybe it was a mistake for me to not do that, because this reminds me I have to do that here. I mean, whether I end up doing this with two alternative patterns, or keeping it as this single incremental one, this is the only way I know if it's an ID, is if it's a string. So I think I should be explicit about that down here as well. I think that was a step too far to leave that out. So I've just amended that. What would the equivalent thing up here look like? Case mod. In module, string is ID, fields, in module, fields, module, ID, fields map, process field. Maybe that is also better. Okay, let's see if that works. Because if it does, maybe I should... Oh, well, it's instantly failed. Why is that? Why has that instantly failed? You all die instantly. Oh, because this needs to be splatted, you fool! I mean, this is just going to be used to explicit pattern matches to deal with optional ID in process module. I guess this is my approach now. I'm just waiting for the test to run, but I'm pretty sure this is fine, because otherwise it would have, I think it would have freaked out before now. Yeah, and the preprocessor test is happy. So I think I'm going to go for that. As with the previous commit, or as explained in, this is probably the clearest way to deal with an optional ID in a pattern match. Okay, good. All right, I don't have to think about that anymore. So what? Yes, okay. So I'm just unwinding the now really quite deep stack in my brain. But the whole point of this was to make it so that hopefully at this point, the interpreter is no longer having to deal with any inline imports. So I can probably close a bunch of these windows. Well, buffers is what I should say. So those are all the explicit imports. I think this can just be functions now, because function import should always be nil. Well, okay, let's do it gradually. I'll stick arrays in there. So if it's ever the case that function.import is not nil, that's going to raise an exception. Likewise here, if global.import is ever not nil, it's going to raise an exception. Else raise. Right, okay. So I think those are all the places where the interpreter cared. I'll just let it soak in its acceptance test for a minute. These are now starting to take a significant amount of time to run, aren't they? Like, it's making me realize that I used to just very patiently wait for these to finish. And when I say very patiently, I was waiting like 5 seconds. But now it feels like I'm waiting like 45 seconds. I don't know how long it actually takes, but it's definitely starting to feel, you know, I'm spending a significant fraction of my life just waiting for this to finish executing. But I mean, so far this is a good sign. So I'm gonna, without saving, I'm just gonna update this to remove, oh, see, this one does need to be a map. What does this do? Oh, well, that whole conditional just goes away. Okay. All right, tests are looking good. So actually, if I make this the end of a word, hopefully it will say there is no more. So let me just do another comb through here. The only places that we're talking about imports are during initialization. Then we're building functions. Yeah, we're mapping over the function imports. We're building tables. We're mapping over the table imports. We're building memory. We're mapping over the memory imports. That's all correct. Globals, we're mapping over the global imports, and then yeah, I think this was supposed to be globals dot map. Okay, I'm going to save it now because the tests have passed. So it was function imports plus functions, global imports plus globals map. Yep, that's right. And yeah, we just outdent that because the imports should always be nil. Well, we know it is because it didn't raise an exception. And then what else talks about imports? Okay, that's it. Okay, great. And that's as it should be. You know, we're only looking at the explicit imports now because all of the inline ones have been desugared. So, well, let's run the tests again. But I think this is going to be you know, something like ignore inline imports in interpreter. And the explanation of that is going to be they've now all been desugared by the preprocessor. These have now all been desugared by the preprocessor. So there are no more inline imports to support. I mean, I hope those tests pass because I've already made the commit, but I haven't pushed it anywhere, so it's fine. Okay, now the next thing to do is to take support for them out of the AST parser. So well, let's start by looking for the explicit string import. So that's okay. That's a top level. That's an explicit import, not an abbreviation. Yeah, build initial context, that's all okay. But here, this is an abbreviation. So this is if we see an inline import, then do this stuff. But I'm going to delete all that because you shouldn't see them no more. So this import here, there now is no local variable called import there. So I'm just going to have to temporarily make that explicitly nil. Because I think you have to provide it. Yeah. Yeah, missing keyword B. So I have to provide that there. Cool. Here's another one. If there's an import abbreviation, but we know there's not going to be, where did that information go though? I think the answer is nowhere. Like it read this import, but then it didn't go anywhere. Well, that's fine. I don't know why I bothered saving all of that stuff into local variables because they weren't used anywhere. Oh, maybe it got copied from here, probably, because this is basically the same code. But again, I can now get rid of that. The import is now going to be temporarily explicitly nil. And this is fine. This is about parsing a top level and explicit import. And that was it. So remove that. Remove that. Remove that. That all looks correct to me. So again, just let the test run, but yeah, hopefully we weren't ever, if we had ever been in that situation where we were currently, where we had an inline import that hadn't been successfully desugared, we would have ended up with a non-nil, well, except in the case of tables where we weren't actually storing it anyway, but in the other cases, we would have had a non-nil import attribute on the AST node, and it would have raised an exception when I was, when I laid those traps for it just then, but it didn't fall into any of those traps. So this is like remove support for inline imports. Remove support for inline imports from AST parser. Sorry, Etienne. These are all desugared by the preprocessor now. I will let that finish, but I think the final thing to do here is to remove these now redundant import attributes from function and global and module. Oh, no, not module. That is where they go. But now that's the only place that imports go. Oh, whoops. Oh, crap. I shouldn't have saved it while I was still halfway through running the tests. Sorry. I am going to run that again from cold because I want to be confident that that previous commit didn't break the test. I shouldn't have been hasty there. But I can still hold on to my buffer. So in which case I don't need that stash, do I? So, and then that's sort of the last of it, right? Is that by pulling that out of the AST, it's now the whole concept of the AST having to represent inline imports has disappeared because now it's totally handled by the preprocessor. Now the question is, can I as easily do the same thing for exports, or is that going to be a world of pain? Because I've got a similar situation going on here with exported names for functions and tables. I mean, my honest feeling is that it's probably worth a try because I've got all of the infrastructure in place. My only hesitation is the difficulty of writing unit tests for it because not just unit tests actually. I'm thinking about the need to create fresh identifiers. So what I mean there is that if we look at the let's look at functions. If you desugar the export, like what this is saying is like, I'm defining a function And let's say that function is called $foo. And I want to export it under some name. Oh, hold on. What does this condition mean? So this is saying if the ID is present. Oh, right. Okay. Yes. Okay. So what this means is if the function already has an ID, then that's fine. That makes it easy to desugar. So if you've said this function is called $foo and I want to export it under the name bar, then that's fine, because the export that you synthesize as part of the desugaring can just refer to the function $foo, right? Because you already called it $foo. The problem is if you didn't give it a name, then this desugaring has to invent a name for that function. So here the ID has to be made up on the spot. But of course that ID has to be unique. You know, this freshness condition here, as is so often the case, conceals a world of pain. But here it says it may be any syntactically valid identifier that does not already occur in the given source text. So basically this has to be an unambiguous identifier. And that's a little bit fiddly to achieve, because how do you generate an identifier that hasn't already been used elsewhere in the module? Well, you have to read the whole module and get all of the function identifiers. Well, in fact, really, it just has to be, it actually doesn't have to be completely fresh. It just has to not clash with any other function. So you'd have to check all the function names and make sure that you weren't treading on anyone's toes. Okay, so let's run those tests. Oh, right. Well, that's fine, because I didn't mean to run the tests at that point. That's what I meant to do. So what we're doing there is removing it from the AST and simultaneously stopping providing the dummy values when we instantiate the node. Those two changes have to go together, obviously. So now let's say remove unused import attributes from AST nodes. Let's say these are now handled by desugaring in the preprocessor instead. Now, the tests haven't passed yet, but I feel pretty confident. That's such a simple change that I feel pretty confident that I'm not going to shoot myself in the foot with that one. So the thing that's annoying about this is that, well, it's my fault, is that this wouldn't be a problem if this ID could just be an arbitrary, if all we cared about was like object equality here. Because, you know, if all we care about is like $foo is equal to $foo, which it is, then you can always do like object.new to get, and now it's Ruby's problem to make sure that this is a unique instance of an object. So now if I compare that object to itself, I get true. If I compare it to $foo, I'll get false. And if I compare it to another new object, I'll get false. So in general, this is a really convenient way to create fresh things. You know, if you want something that's unique, you can always just say, hey Ruby, give me a new object, and then it's Ruby's problem to give you a new object. You don't have to worry about this somehow being the same as some other object in the system. So I could make fresh identifiers in that way, but then I think the parser is going to be confused. Like when it goes to parse function, you know, it expects the ID to match this regular expression. So if the ID that was in the S expression was not actually a string that began with $, which is what IDs are supposed to look like, and instead it was like just an instance of objects, just a plain Ruby object, then this isn't going to succeed. So I either have to cook up some convincing looking identifiers like this, in a way that makes them reliably fresh, or something else. How do I want to do this? I mean, you can always bodge it by just, you know, having a supply of identifiers that look like, you know, $double_, you know, fresh 1 or something, and just hope that nobody uses that isn't legitimately an identifier in the existing module. Maybe I'll do that just to get things started. But otherwise it's going to make the desugaring quite complicated, because it's going to need to collect all of the identifiers in the program in order to then be able to compute a fresh one. Like if you know that in a particular module the complete set of identifiers that have been used is like $A, $B, and $C, then you're able to pick one that's not in that set, right? And I mean, it might not be totally obvious how to do that, but, you know, as a human, you could pick $D, right? Like, or whatever. I mean, what I would do in that, if I've got a finite set of identifiers in the program and I need to make a fresh one, I think what I do is just pick an arbitrary one, like pick the first one, and then just append something to it. So append an underscore or a prime or something to the end of it, and then check to see whether that is an identifier in the set. And if it isn't, then congratulations, you found a fresh identifier. And if that does happen to be in the set, then just append another prime. And like because there's only a finite number of identifiers in that set, you will eventually create one by appending enough primes or enough underscores or whatever to create an identifier that wasn't in the original set that you started with. Or of course you could, you know, you can always find some fixed point of this. You know, you could, well, I was going to say you could just generate random ones, but I suppose that's not guaranteed to terminate in the way that just simply appending something to an existing identifier is guaranteed to terminate, because if your random number generator is really bad, you might keep picking the same identifier over and over, which happens to be in the set. Whereas, for mathematical reasons, if you keep appending stuff to a string, you will eventually get a string that wasn't part of the initial set. Anyway, I don't want to do that because it would be very annoying. So do I want to, I guess this is what I have to decide. Do I want to support identifiers that are not strings just so that I can easily mint fresh ones by calling object.new? Or do I want to... I mean, I suppose another option is that I could dispense with this rubbish in the first place and have identifiers actually represented as objects, like the S expression parser could be richer than just S expressions. Like it could actually, when it sees an ID, it could create an instance of some kind of identifier object, and then if I want a fresh identifier, I can instantiate identifier and just not supply a name, and then that becomes like, that gets treated as just a unique identifier. But then that's making the S expression parser a little bit... Well, I mean, I suppose it's fine for this to have stuff that's... Well, I mean, it's already got tons of stuff that's specific to WebAssembly. Like it was fun to imagine that this was just a generic web expression parser, but... Not web expression, S expression parser. But it has to deal with WebAssembly comments. Yeah, but otherwise it is pretty generic, actually. Like here, parse atom could actually return some kind of identifier node. Right. This is just, is it a string that begins with, is it just a string that begins with $? So hold on, let me think. Is there a way that I can... I'm just going to think about this for 1 minute, and then I'm going to just pick an approach. So that matches. Obviously that doesn't match. And that doesn't match because that's not an identifier. You know, this would be better like, you know, func. So if this was like, so actually if it's not a regular expression, but then what's this actually checking? Right, it's checking... Oops. Right, it's just asking is a... So this would have to be like... It would have to be something like this to make it work. Oh, whoops, no. That's not what I want. So then if it started with $, then that would be an identifier. And if it was specifically an instance of, well, object or whatever I use to represent identifiers, then it's an identifier. Whereas if it's like a hash or something, then it's not. Yeah, I mean, I don't really like this. This is slightly hellish, isn't it? I think that for now, to break this tedium, I'm going to go with the sort of what's the sorry, I'm just trying to think about if I wanted to just generate, if I wanted an enumerator that just gives me more and more, it's like step or something. Maybe it's numeric. I'm just trying to think what like a well, actually, I suppose you can always say like, or like 0 up to infinity, and then you can always like you know, like that kind of thing. How am I going to do this? It's surprisingly hard for me to choose a way to make this work. Also, this abbreviation is recursive, right? Like, for imports, you're just permuting all of the bits of the S expression to be in a different order. Here, this export name can be followed by some arbitrary expression, and so now you have to insert that expression here, but that expression could itself contain abbreviations, so this whole thing needs to be sort of recursively expanded. Yeah, here we go. The latter abbreviation can be applied repeatedly if ... contains additional export clauses, possibly followed by an import. So yeah, it's a little more complicated anyway. Okay, I feel like I've faffed around for too long on this. I want to do something deterministic so that I can write a unit test for it. So, well, let's start by doing that. Preprocessor test. So let's imagine that we have a function. It doesn't have an import. It says oh god, what's this going to look like? Is that like a nice one-line function? These are all a little bit spicy for me. About I32. Even those are quite spicy. Maybe const was my best bet. To just pick something that's like int literals. I think something like that is probably going to be the most unspicy imaginable. Okay, let's take this first one. This bad dude function. Because that's like fun, isn't it? So something like that. And for now, that's probably the expected. Oh, well. It has to be. So we have to say module. I'm glad I ran that. Okay, so that's fine. But what we want it to be is export so that's what the input was. The expected is export name right. So this is actually going to exercise the fresh identifier thing because this function doesn't have an ID. So this is going to have to be export i32.test func $fresh 0 and then func fresh 0 result i32 return i32 const oh bad dude. So that's what we get is like first an export and then a function definition. So that export gets sort of peeled off the front of it. but this fresh identifier is what makes the connection between this newly synthesized top level export and the function definition that previously didn't have an ID. So again, well, this whole thing needs to be in a module, doesn't it? Can be an array. That can be an array. This can just be return. That gets exploded. I guess that gets exploded. Okay, well, that's not very beautiful, but I think that's what we want. To put a comma in there. So module export name and then func with the identifier. And then we've got the actual function definition. Yeah, okay. Right. So obviously that doesn't work. How can I make it work? Here I can say in func. So we're doing the case where the function doesn't have an ID, which, you know, again is going to have to be explicit. Export name. And then this literally is like rest. Then this is going to have to be func. Nope, sorry. Oh, crap. Yeah, okay. Actually, there are two. You know, there are two arrays here. So this needs to, this thing, process field, needs to return an array of arrays to make that work. So this needs to be flat map. And this needs to be like that. Because in general, this might return, well, in this case, it returns two. You know, previously, one thing got rewritten to one thing, but here one thing gets rewritten to two things. So we need to lift this up to return an array of expressions, and then those get exploded out by the flat map. So I think, yeah. Oh, what? I don't understand. What have I, oh. Right. So actually the identity here, the do nothing, is no longer just the identity. It's like this has to wrap it. Okay, but that looks okay. Okay, so assuming that that hasn't broken anything, now this has to be this is going to be the export something something, and then this is going to be the func something something. What's the export something something? Name func ID, which we don't have. So for now, let's say ID equals fresh 0, because I think that's what I was looking for there. Obviously, this is going to be a problem more generally, but let's just stick with that. So I think that is the export. Export name and then func ID. Now this needs to be func ID and then the rest here. And ultimately we're going to need to do that recursively. And that's not hard to do. I'll just call process field on this array here and splat the result. But for now, I will just leave it as one level deep because that's actually all we need. And then I can write a separate test. So there we go. Okay, so that's like one level of unfolding it. What has that done? Oh, nothing good. Unhandled exception. Wow, well, why hasn't... Why has that caused such an immediate problem? Build initial context. 177. Oh, is this going to be a uniqueness? Yeah, okay, fair enough. The context is not well formed because it's going to have duplicate identifiers in it because of this. Okay, that's fine. I'll accept that. So let's just say that when we initialize this, we start, let's do this. So we start off by initializing this to 0. We make this and then we increment it. So, oh. that not a thing? I guess not. Oh, hold on. What was it complaining about before? Oh, it was complaining about the fact that it was nil. I'm sorry. I just didn't read the error. Okay, that is totally fine. We just have to... Hold on, I'm confused. Why is it nil? It's because I have been living in Britain. Wow, that is... I think that that's the most rudimentary Ruby error that I've made in this project so far. So that's fun. Spelled initialize wrong. Okay. It's only 1:30 a.m. Okay, so... And you can't do this, can you? That would be... Yeah. That's immoral. Okay, so does that... Okay, so that's happy now. So I think, although obviously I'm not... It's not very principled to just invent this. To just invent that. I would say it's better than nothing, or at least it gets this process started. I can put a to-do in here to do find a better way. But I think this is... I think I've got something I can commit here, which is like... Well, as long as it doesn't break anything. Now we're expanding inline exports for functions. And what kind of thing are we allowed to export? Like, what's the surface area of exporting? Functions, tables, memories, and globals. Okay, well, that's the same as imports. Is that a coincidence? I don't think so. Okay. Okay, great. So, okay, but there are two separate changes here. And I probably already had it separately staged, but I screwed it up. So remove all that. Yep. Okay, so that is... And then the rest is... Yeah, that makes sense. Okay, so let's just say return list of expressions from process field. And I'll say, although inline imports only, although the abbreviations for inline imports only replace a single expression. With another single expression. This isn't true in general, e.g. inline exports produce two or more expressions. So we need to support, to support inline exports, we need to be able to return more than one expression from this method. Well, let's not say expression, let's say fields. A single field with another single field. Okay, and that's more specific. It's not an expression at all. I mean, I suppose I could, I suppose I meant S expression, but I think this is, to be more specific is better. So, so what should I say here? Expand. So it's like this. Expand inline function export abbreviations in preprocessor. And I'm definitely going to have something to say about this. Like all inline function exports, well, like all inline exports, this involves potentially inventing a fresh identifier for the function if it doesn't already have one, so that the generated export can refer to it. For the moment, I've bodged this with an obscure identifier name and an automatically, well, with an auto incrementing suffix, but we need to find a better approach in general. Well, but this isn't completely reliable, so we need to find a better approach in general. Let's say, for the sake of making progress, I've bodged this. Bodged this by using an obscure identifier name with an auto-incrementing suffix. Okay, fine. No tests broken. So let's support the recursive case. So it's going to look a bit like this. Actually, let's format this a bit more charitably so that there's a tiny chance of seeing what's going on. Because the point of this is that now we've got separate export and function definition, right? I think that's right. And the reason I've done that is so that I can do this without losing my mind. So I think what needs to happen here is well, let's test that what was it, in literals? Let's test that, so that this umax. Let's test that what happens when you have two functions, right? So this is umax. So I'm a little bit confused about what we do about the order of things here. But for now, I'm just going to wing it and assume that what we do here is we interleave these. Like, I really don't know how we're supposed to deal with interleaving exports and function definitions, and I don't know whether I support this properly yet. Yeah, just realized though, that is not umax. That is, let's get the details right. Okay, so I'm hoping that that test passes. What have I done wrong? Oh, here, I need a comma. Okay. I mean, I assume that it's fine. I assume that it's fine that I've put them in this order. Or yeah. I mean, the tests are all passing, so I guess it's not a problem. So here, I'll just say add another unit test for expanding export abbreviations for multiple functions. So I mean, that, you know, that's checking that it does the thing that I wanted it to do. But the thing that I'm really interested in is a function that's got multiple exports. So if I made this test1 and I made it, I mean, is this how it works? You can say export, 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 yeah. Then here's what I want to see. I32 test1, I32 test2, and they're both referring to the same fresh identifier because we only need to create one identifier here. It's just both of these names are referring to the same, are exporting the same function. So I'm expecting the test to fail now because I haven't implemented that yet. Yeah. And what I'm expecting to see here is that one of the exports gets desugared and the other one doesn't. And yeah, sure enough, we've still got this I32 test2 abbreviation inside the function definition. So the way to deal with that, like I said, is that we just have to recursively process this field here and explode the result. And we get a runtime error because there's no pattern match. I don't know why it hasn't said that. Oh, hold on. Oh, yeah, it's because it's fallen through to the default case, right? So it hasn't even tried. This is still the same result. It hasn't even tried. Because although it has recursively called process field, that is now a no-op. So I need another one of these for functions that do have names. Oh, and I guess I should put this first. Hey. All right. So let's run the tests, but I could probably also stick an import on the end. Let's do that too. Well, I can do that in a separate commit, I think. I'm going to make this 3 because I think for it to work 3 times, it needs to be recursive in both cases, right? So for the first, this is the first case it hits and it needs to recurse. But then in this recursive call, it's going to hit this second case, and then this needs to also be recursive so that for the third time, it comes and uses this clause again. So I think this, to really demonstrate this, we need to put 3 of them in here. Tests are looking okay. Add support for multiple inline function export abbreviations in preprocessor. I don't think I need to say any more than that. It's just a thing that we need to do. And finally, let's just have a test for So we know what imports look like. It looks like this. So I think what that will look like so I'm thinking here about what happens if we've got a function that's exported a few times and then it turns out it's actually not defined here, it's just an import. So that means we would have, you know, multiple applications of this abbreviation peeling off these exports in front of it, and then what we actually get at the end is funcID import. So there is no function body, it's just an import. So I think it would be something like this. So let's say this is imported from my module and it's called bad dude, which I think is what this was saying, yeah. So I think what we should expect to see here is not a function definition. We should expect to see an import. So we should see import my module bad dude. I think that's right. And I'm hoping the test is going to pass. No. What have I done wrong this time? Too many square brackets? Yeah, I think that's right. Oh, that hasn't worked. Test 1, test 2, test 3, import my module, bad dude. Oh, of course. I forgot its name. Okay. So that does work. Cool. Add another unit test for expanding inline import and export abbreviations for a function. Inline function import and export. Okay. Well, I mean, this seems to be working okay, doesn't it? So can we do the same for the rest of them? So table, memory, and global. Oh dear, this is using too much CPU. Sorry, math jacks. Okay. So table is a similar deal, right? I'm just trying to think what the best way to write the test for that is. Oh, tests are still going. So, sorry, I'm not really saying anything, am I? I'm just trying to pick a representative one here. Maybe something like this. Like they're all quite different, actually. Hence my hesitation. Maybe I'll pick like that one because that's got more of the features of a table definition. So something like this. Table 01 funcref. Oh, hold on. That doesn't. That's not an inline export. Okay. Let's try again and actually think this time. Yeah, I think something like this that I was originally going for, I think would be. Let's go for this one. So something like this. something like that. And what it's going to look like is export A, and I think it's going to be like that. Export name table ID, and then it's going to be table ID, and then the rest of what came after here. So whatever was after the export, which in this case was 0, 1 funcref, now that just comes after, well, in fact, this whole, I think this becomes the whole thing, like that. I think that's right. Yeah. Okay, so okay, that doesn't work because we haven't implemented it. So I think actually I might just, maybe I'll just go nuts and add this in here, table, because I've sort of already established this approach up here. This goes into kind. Again, this goes into kind. That's kind. That's kind. So I think this is it's the same pattern for the abbreviation in both cases. Yeah. Okay, great. What effect does that have, if any, on the tests? Again, I don't, because this has all been a bit ad hoc, I don't know how well supported explicit exports are for these things. And again, I think there's probably limited value in testing, you know, what happens if the table is also imported and stuff, because I've kind of already covered that with functions. So I think merely making sure that this works for tables is probably like enough at this point. Okay, well, this is looking fairly hopeful, so let's put together a commit. Okay. So it's going to be like this, isn't it? Expand inline table export abbreviations in preprocessor. And I don't think I need to... Oh, no. Why has that happened? Oh, hold on. No, okay. Key not found, shared table. Let's just have a quick look at that. So in module 2, key not found, shared table. Okay, so this was during... This is during module instantiation, trying to instantiate module 2. Puts building tables, imports, so let's just see how this looks. Well, that commit's not going to happen, is it? Import module 1 shared table. $10 funcgraph. And we need to look at exports as well. Okay, so, oh dear. Okay, so let's look at exports fetch module name. Okay, so we've got spectest and module 1. So if we fetch module 1, it's got call 7, call 8, and call 9 in it. Module 1, call 7, call 8, call 9. So those are all being exported successfully, but shared table is not being exported. I mean, are we even trying to export tables properly? Like, this doesn't seem to have worked. Let's have a look at the interpreter. Oh, right. Well, we'll have to do this, won't we? I think that's why that wasn't working. Okay, cool. Okay, let's run the rest of the tests. So this is add tables to exports, basically. Add explicitly exported tables to exports during module instantiation. And then we're going to say we need this to work. We need this to... Apparently nobody cared about this before, but we need it to work if we want to expand inline table export abbreviations. And then this is whatever I started writing up here. Yes. I'm not writing that sentence again like a chump. Okay. I am going to see what happens if I just wing it and add the other two kinds to this. Without adding unit tests, because I feel like it's sort of diminishing returns at this point. I suspect this might suffer from the same problem because in the interpreter, we weren't populating this for memories, so I'm sort of expecting that to break. So what I'm doing here is just plumbing in. There's only one memory at the moment, and this isn't really very convenient. But that's all I've got. So I'm sort of anticipating a test failure that isn't necessarily coming here, but I sort of assume that someone somewhere is going to care about exporting a memory, but maybe not. I might be able to avoid this. I don't know if I've got any tests that are currently exporting a memory. No, it doesn't look like it. So actually I can undo what I just did there. Because miraculously, nobody cares. So I will amend this and say, I haven't added unit tests for this because it feels like the returns are diminishing. As long as the acceptance tests keep passing, I'm happy that expansion of inline imports and exports is working correctly without needing to exhaustively test every possible permutation. Okay, and then I don't see why I can't add global here, again, as long as it works. So again, let's try running the tests. It looked like global exports were hooked up correctly in the interpreter. So fingers crossed. So this is hopefully going to unpick all of the inline exports as well. In fact, I think maybe I could fold this into the previous commit as long as everything works. So let's just give it a second. But I think this might be more of a git commit amend, and then I can just bundle both of them in because it's not, they're not meaningfully different changes. This is really me just piling in the rest. But yeah, that's on the assumption that I don't need to drop in a middle commit to fix some breakage that this is going to cause. It's looking hopeful so far. I just hope, well, yeah, that's the nature of hope, isn't it? I think we're going to get away with this. Yeah, nice. All right. Well, then in that case, this is going to be memory and global export abbreviations. Working correctly in general. Okay. So I need to wrap up in a minute because my brain is very tired and I can't really concentrate anymore, which is why I'm going so quiet. But what I would like to do is unpick it from the interpreter again. So is it all like exported names is the magic word? So it says here, use globals exported names. That kind of makes it feel, oh, right, but okay, I never did do that. So if I unpick, well, it sounds like I could probably remove this and this and this. Get rid of that. Get rid of that. Get rid of that. Does that work? So can I... So this ignore inline imports in interpreter. I mean, this, you know, this would be essentially the same commit, right? Ignore inline exports in interpreter. These have now been desugared by the preprocessor, so there are no more inline exports to support. Looking good so far. So now I just have to unpick it from the parser. I'll let this keep running, but I'm relatively optimistic about this. I think it would have blown up by now. Exported names. So here we go. This can just be nil. Well, perhaps empty array. Yeah. Oh, so that it wasn't even being used there again. Let's make that the empty array. Again, not being used. So yeah, it's actually only those two AST nodes that even can store it. Yeah, fortunately, that commit didn't break any tests. So I think there's another commit that I'm going to be able to copy from here. So this is going to be remove support for inline exports from AST parser. These are all desugared by the preprocessor now. So yeah, we don't even need to worry about throwing the syntax away anymore because it is literally gone from the S expression. And then yeah, while that test is running, we just need to remove, well, we can remove them from the AST entirely and go back to the parser and just unpick this, so we don't need to provide them anymore. I think I'm going to stop that and just trust the process. So what does this look like? Right, that does involve changing the parser. So it's going to be remove unused exported names attributes from AST nodes. These are now handled by desugaring in the preprocessor instead. And I think that's accurate. Yeah. Okay, well, let's run them through. That was me killing it, right? Yeah. So I'll let this run for a final time. But while that's going, I'm just going to review what I've done in this session, which is, well, so maybe this could ignore all space and color words. So you can see I've removed exported names and imports from function and table and global variously, depending on what's actually supported inline imports and exports. And that was just driven entirely by what was needed by the current tests. So yeah, we needed to parse imports properly during population of the initial identifier context. But then we could just remove all of this stuff. So reading the inline exports, the inline imports, sticking them on the AST node, removing the inline imports, removing the exports, the imports, exports, imports. And then, yeah, getting into the interpreter, no longer storing the exported names, no longer looking up the inline imports, no longer looking at the exported names, no longer looking at the inline imports there. And then this is the inline export support. So yeah, I feel pretty good about that. That involved, and I mean, obviously I've had to add a preprocessor to make that happen, but that feels like this is now very localized. Like, I think this was the main thing that I wanted to get out of this, and it wasn't until now that I sort of realized it, is that I want this concern to like be wrapped up in one place. And previously, as this diff shows, it was just like spread all over the parser and the AST and the interpreter. It was having to deal with all of that stuff ad hoc, whereas now it's just centralized in one place. Okay, so the test passed. Let's do the traditional pushing up to GitHub. And then hopefully we'll see the test pass on here in a sec. So that's really good. I'm glad I did that. Find a nicer way of generating exports from inline export abbreviations during module instantiations. Squirreling away on the runtime representation is a massive hack. Okay, well, I have found a nicer way, which is to not have them. They're gone now. Extract parser for parsing inline export abbreviations. I don't think I need that anymore, because the preprocessor does it. Implement the abbreviation in a more principled way, which makes the export explicit. That is what I've done. Can we expand abbreviations without having to worry about instructions at the same time? Excuse me. Yes. And this was the thing that this is why I was hesitating to take this approach in the first place, is because I thought that the preprocessor was going to have to touch the instructions, but of course it can just leave them alone. It's just the identity transformation on instructions, at least it is at the moment, because I'm not trying to do unfolding in the preprocessor, but maybe that's another thing that I could be trying to do, but the answer to that is yes. Okay, so this is about supporting a new abbreviation. Decide on a systematic approach to S expression abbreviations. It looks like I'm doing that. Okay, so I've ticked a lot of those things off my list in this session just by implementing the preprocessor, and it has led to a more principled approach, I think. Great. The test pass. It's 5 minutes ago. Oh, I guess that's when I actually made the commit, but you know. Whew. Wow. All right. Well, it's now quite late here, so I'm going to stop. But that was a pretty good session. I'm really glad that I got that preprocessor plugged in there. I mean, with the benefit of hindsight, I should have done that a long time ago, because it would have saved me building all of that ad hoc complexity to begin with. But it wasn't until now that I realized that that the trade-off was worth it, you know, that having another stage in the pipeline was worth it. But it is now very clear to me that that is the right way to do it, even if it means that, you know, I don't know, I haven't timed, obviously, I haven't timed whether the introduction of that preprocessor has made the test go even slower, and maybe it has, but I think for the sake of centralizing that concern and making the code easier to understand, it's absolutely the right thing to do. So that was a little bit of a slog. It was a long session, but I wanted to break the back of that and like get it plugged in, get it working convincingly. And I think it is working convincingly now, because I've got imports and exports being expanded, and now the AST parser and the interpreter don't need to deal with them, and they were probably the hardest bit. So now there's a long tail of other abbreviations that I can port over as and when I want to. I mean, ultimately, I think it would be good if there's going to be some kind of principle at work here. I think the principle should be all of the abbreviations are handled by the preprocessor, and then the AST parser and the interpreter only have to deal with the sort of platonic ideal of the AST without having to know that there are multiple different ways to express the same thing. And at the moment, there are still loads of special cases and defaults and stuff like that, but I'll deal with that next time. So what that means is I will say goodbye for now. I always just say the same thing, don't I? But like, I'm very grateful. If you are by definition watching this or hearing this, or I guess potentially reading a transcript of this, but however you are consuming these words that I am saying right now, I'm very grateful to you for paying whatever amount of attention you are paying to this project. I'm conscious this wasn't a super gripping session. I'm starting to say that every single time, so maybe I just need to recalibrate my idea of what constitutes gripping. But yeah, I'm very grateful for your interest and attention, so thank you for caring a tiny bit about this. I'm gonna keep going, so I will see you next time. Bye bye. Stop.